Okay, at the beginning, when I call when I call the state, the name of the country, each group has to stand up and say in their own language, hello. Okay, if you have a flag, use your flag also, okay? Okay, I think we are waiting only for another class, but we are almost all present. So I think it's time to start. So yes, I'm really, really happy to have also this here, all of you in Bologna today for celebrating your work. Okay, what you were able to realize during this year in the framework of our European project, Harema School. Okay, here there are present people from 16 countries, and this is a great success. And now, okay, I'm here with Veronika Sokorova, a friend and also colleague from Czech Republic. She's a delegate from Euromines, that is a huge association of mining companies in Europe. And together with other friends and colleagues from other countries. So now for starting well, we need to know each other. So I'm going to call each team by calling the name of the country. So when you listen the name of your country, you stand up. If you have the flag, use the flag and say hello in your language. Okay, let's start, okay? We are really, really glad to have here today the team from Finland. Where is Finland? Say hello, hello in your language. How do you say hello in your language? All together. Okay. Okay, now Bosnia and Herzegovina. Okay. Okay.
Now, students and their teachers from Austria.
Austria. Okay.
Now we would like to welcome the team from Portugal.
Portugal. Hola, hola, hola. Okay. Hola. Okay. Okay. Now, Hungary. Hungary. Where is Hungary? Okay, two teams. Okay. Okay. Estonia.
Now the team from Estonia.
Estonia. With a very, very small flag. Okay. Okay.
Now my fellows from the Czech Republic.
Okay. Okay. Sweden, the team from Sweden. Okay. Yeah, they are too shy. They're too shy. Okay. Now it's time for the team from Latvia. How do you say? Ah, okay. Okay. Yeah, Spain.
Now please the team from Spain. Spain. We hope that they arrived already. Spain.
Spain.
Spain. Ah, just arrived.
Okay, now it's time for Germany. Germany team. They are too shy. Greece.
Now the team from Greece.
Greece. Kalispera? No? Karimera? I don't know. Okay. Yes, we have here also people from Netherlands, Slovenia, and Belgium, but not with the student. But the last teams are from Italy. Hello? Huh? How do you say hello? Okay, let's start with the conference. Okay.
Okay. Now, I have to introduce the most important person today here, and that's Armida Torregiani. Because without her, this conference would never happen. Actually, this project would never happen. And she's holding on for many years already. So I'm sure that she will be able to tell us a little bit about the project, what we have succeeded to do in the last couple of years. So Armida, the floor is yours.
Okay. First of all, I'd like to thank all the people that also this year made possible to have the conference, the European conference, because it's, believe me, it's really hard and complex, an organization like this. So you can see a lot of names. I'd like to thank with all my heart also the consortium partners, because they support us continuously during this year. So a big applause for all these people. Okay, thank you. Thank you. And now, 2 minutes for telling something about our project, because also we are in streaming on YouTube. So maybe there is somebody that actually doesn't know many things about our project. So very briefly, okay, what is RM School project? Raw Matters Ambassador School is an innovative program to make science education and career in raw material sector attractive for young people. And the project started in 2016 with 6 partners. Then the partners became 8. And now, the project involves 30 partners from 19 countries and a strategic consortium composed by schools, university, research institutes, and museum and companies. So during these years, the program have already trained a lot of students, as you can see from this slide, and organized many events. So we were able to reach a lot of, we can say, generic public. So we are fostering a large action towards society. To try to make understand, to raise awareness about the importance of raw materials and circular economy for our future. Okay, the idea at the base of our project is to propose an active learning at school by involving students both in lab experiment and in communication activities. So in order to transform the classes into lab, the consortium developed during these years a lot of educational tools, educational games, laboratorial toolkit, digital activities. It is now everything free available on our website. So in particular, now I'm speaking to the teacher. If you want to use something, this material is also available in many languages, not only in English. Okay, and as regards the methodology, okay, in RM school, all the students are introduced into some RM-related topics by RM ambassador, who are experts from the consortium or trained teachers. Some classes, okay, the classes perform a lab experiment. Some classes also perform study visiting companies, but all students are asked to play an active role in science dissemination. So we can say that you, the trained student, becomes multiplier of knowledge. Okay, you are now our young RM ambassador. Okay, and how can you diffuse the message? Okay, for example, you can create some communication product like poster, videos, website. If you are curious, you can have a look at our gallery page in the website and also in our YouTube channel. Please enter into the conference hall and take a seat, okay? In silence, but enter, please. Okay, and also students can become real collaborator of expert by working with us during public events, and such as European Researchers' Night or today. So we have, for instance, the support from one class from Liceo Copernicus, that is a scientific school in Bologna. Okay, and I have a lot of things to tell you, actually, too many things and too short time. But okay, only two things. Okay, during this summer, we were able to organize two very interesting initiative, an international summer camp in Bosnia-Herzegovina, thanks to the organization of Banja Luka University. During this summer camp, students have the chance to visit, for instance, Green Mine, and they learn a lot and also have a lot of fun. And the International Science Fair in Netherlands, thanks to Vetsus. It was a great experience. And actually, for telling you something about these 8 years of project, I think is not enough for one day. So I prefer to show you some videos. Yes, and I want to finish with this phrase that I want to leave you. If you want to go fast, go alone. If you want to go far, go together. Yes, this is my lesson. That's what I have learned.
Okay, now a little bit of fun for you, all of you, we hope. We would like to invite our colleague from Spain, David Leon. And David, I think David will present his Kahoot, right?
Yes.
Okay. Sorry.
First of all, okay, now take your mobile phone, okay? And this is the password, the Wi-Fi of the conference center. So now we have a competition, eh? Okay.
We will give you a couple of moments just to get connected. Hands up who managed to get connected. Who is online? Who is online? Some more minutes. Will you take over now? Yeah. Or, yeah. Okay. Now my colleague David is going to explain what is ahead of us.
Good morning to everyone. I think that now all of you are connected to the Wi-Fi, and we can start with the competition. I think that all of you know about Kahoot, no? And in Kahoot you have, in this case, 4 options, and you must be correctly in the answer and very quickly to obtain more points than your rivals. And now you have you should join to this web, the first one, and put this pin code, okay? Please, when you connect to the Kahoot, don't put only your name. Put, for example, David Spain or something like that, because maybe there are a lot of David or Sarah here.
Please, fast, take a seat. Come on. So you are in time to take part to the competition. So use your mobile phone, insert the pin of the game.
Prova. Prova.
Do you know how many are here?
Two classes arrived now.
Yes. Yes.
Okay. I think that now we can start.
Okay, so we can start now, I think. Just 10 seconds more, and then we will start. It's never stop. Okay, silence. We are going to start, okay? Remember, be faster than your opponents. So, first question. Okay, let's go. This is the RM Schools European Conference number. Okay, this is easy, no? Okay, very well, very well. Oh, the first one is Maresa now. So we will continue. Second question, how many countries currently collaborate in the Airman School network? Okay. Very good. I think that the first two are very easy, no? Who is Danilo? Who is Danilo? Danilo, who is Danilo? I don't know who is Danilo. So, third question. What is a raw material? Oh, very well, very well. El piccolo. El piccolo. Fourth question. Which property is necessary for a raw material to be considered critical? This is more difficult, I think. Okay, very good, very good. El piccolo again. Who is el piccolo? Who is? Who is el piccolo? We don't have any el piccolo here. Congratulations. Okay, the next question is, select the critical raw material. Yeah, of course, beryllium. Beryllium is a critical raw material, okay? Oh, it changes now. Next question. Platinum group metals include this one was more difficult, no, for you? Yeah.
This was quite difficult.
Elon Musk, we have Elon Musk here. The next one, select the correct option. Of course, for example, your smartphones have a lot of critical recoverable materials. Fagioli. Who is Fagioli? Who is Fagioli? I don't know. Is mining always harmful to the environment? Yes, very well. Mining is very good, but we have to do a good mining. Next one. What element mainly appears in the batteries of smartphones? the most important element in batteries. Okay, this was very easy, no? Fagioli. Who is Fagioli? Where is Fagioli? Where is Fagioli? No?
Okay, the last
Okay,
one.
we have the last one now. Remember, be faster.
Okay.
The last one. Which element is not related with a more circular economy? Very well, very well. This was more difficult.
This was difficult because the statement was not related to the circular economy. Okay, so now we are going to discover the winners. Okay.
The podium, we have the podium. The third one is Barney from Hungary. Please come on. And the winner is Fayoli. Please come on. Please come on, come on. Come on with us. The three of you, the three in the podium. The three. Please. Please, Elon Musk and Barney from Hungary. Come on also. The second one and the third one, please. Come on. They went crazy with that.
Let's start.
Thank you very much. That was almost like winning the Olympic Games, so congratulations, and let's start. Let's start with presenting your projects. Now, let me introduce the structure, how we will do it. We will always invite a team from a particular country to join us here on the podium. Then we will show their short video, and then we will ask a question or two, depends on time. So let me invite the first team. It's the team from Liceo Rambaldi Valeriani from Imola. So could we invite them to join us here on the podium?
audio. We cannot listen the music. Yeah.
Now and then I think of when lithium was enough. Like when we said, don't worry, it's not going to end. Told us out that it was right for us, and it was good for our batteries. But you overuse it and it risks to disappear. We have to find a solution. Something bad is gonna happen if we still do nothing. It's a problem that we gotta solve, but we are ignoring it. That feels so wrong. No, we didn't have to ruin it all. We can see that from the darkness we're destroying the world. I guess we have to change that thought. Lithium is in danger and it's all our fault.
I'm gallium, a soft silvery blue metal. You can find me here on the periodic table. My alloys with other metals and their chemical compounds, especially gallium arsenide, have various applications in the electronic sector. Now I'll show you the most common ones.
Hey, do you know I have just bought a new phone? It's fantastic.
Really? I hope you know that your phone contains dysprosium.
Dysprosium, I have never heard about it.
Yeah, dysprosium might seem like a minor detail, but it has a lot of effects on your phone, both positive and negative.
Welcome to Exploring Bismuth, the multifaceted metal.
Today, we will delve into the incredible properties and diverse applications of this unique element. We will uncover its fascinating past, its role in the present, and its potential in shaping the future of technology.
Bismuth is an ancient element, and it was one of the first metals to be discovered. Bismuth was used by the ancients as cosmetics, medicine, alchemy, and metallurgy.
We will talk about natural rubber, analyzing different aspects, what it is, its history, from what and how it is produced. Natural rubber is a product widely present in everyday life, yet still today there are many doubts about it, how it is produced and what are its potentials. In this regard, the first thing to know is that it is a material produced thanks to the latex of the rubber tree.
Okay. Okay. Only 3. I'm quite surprised. Yeah, I'm quite surprised because from this school, 3 classes worked on this project, no? So, okay, please come here. Okay, first of all, okay, you prepare a song, okay, the text of the song. Who had the idea to create the song? And okay, how do you think about a song to raise the importance of raw materials?
Okay, we heard about that project, and we thought that we wanted to do something creative, something that the people could like, to hear, but at the same time, maybe to discover something, to learn something new about an important matter, which is the raw materials, for sure.
Okay, what was the most difficult part of your project? Okay, if you want to go a little bit more in the center, no, because otherwise, okay, we can ask to these girls, okay? Do you want to say something about the most difficult part of this project? A little bit of applause. Okay, she's not able to speak, just on the stage, I'm sure. Okay, so do you want to say something about your experience in Arema School project? Do you want to say something? Yeah?
Well, last year we were able to find the time to make this project. It was not easy because we were full of problems and with the school and with our hobbies, but we find the time to make a good project because we really enjoy it, and it was a really good experience.
Okay, so they learn, enjoy something. Okay, okay, congratulations and thank you again. Okay, okay, you can go down and we can call the other team.
Yes, please. Now let's move to the next team, and this team is from Hungary, from Kazinci Ferenc Gymnasium from Győr, from Hungary. So if I can please ask the team from Hungary, from Győr, to join us here.
Where is the team? Okay, please come here.
Come here, please.
When we observe nature, not only do we witness life, but an opportunity to innovate, to discover, and to forge a path towards a sustainable future. Our mission has led us to the heart of bioplastics. We're exploring the potential of thermoplastic starch and the plastics we can derive from litter and food waste.
Bioplastics, by definition, are those born from renewable resources or biomass. These materials, due to their natural essence, are compostable. Unlike traditional, fossil-based plastics, these bioplastics can be recycled and reused almost endlessly, offering a far more sustainable and environmentally friendly alternative. So they present a promising step in our efforts to combat the ever-growing plastic pollution crisis.
At the core of our experiments, we've been working diligently to synthesize these bioplastics. Through gelatinization of starch, simple process involving heating of the starch molecules in the presence of water, the secondary interactions between polysaccharide chains are severed, after which the hydrogen bonding sites, namely the hydroxyl groups, will start to engage more water. This results in the disintegration of the granule structure as it dissolves into the solution. Given enough time and other factors, such as a cool and dry environment, the broken down chains of starch are reintroduced to form a more or less crystalline structure as we're able to produce a firm gel. The reinstatement of hydrogen linkages within the retrogress starch engenders its superior mechanical attributes.
However, to ensure that our bioplastic is flexible and robust, we make use of softening agents such as glycerol in the gelatinization process. This process not only enhances the pliability, but also permits the thermic molding of our product. Other additives, such as acetic acid, are added in an effort to promote hydrolysis of the starch and to produce amylose acetate esters, which increase the tensile strength of the plastic after retrogradation.
In our tensile strength tests, the bioplastics have demonstrated resilience. Their versatility allows for a wide range of applications spanning from sustainable food packaging to innovative medical uses. This strength, combined with their eco-friendly nature, positions them as a frontrunner in the evolution of sustainable materials for the future. The results from our preliminary tests on cellulose-based plastics made with cellulose extracted from discarded banana peels have also been promising. The bioplastics derived from cellulose exhibit superior tensile characteristics due to the robust cellulose acetate ester formations. While our first iteration of bioplastics showcased potential, our refined version with adjusted additive content proved to be even more promising. The ability to tailor the properties of a certain material for a specific application by the alteration of only a few precursors is a great advantage of such plastics. Of course, challenges remain. perfecting the properties of TPS and cellulose-based esters, expanding their applications, and ensuring a divisible but efficient production is vital before moving on to large-scale manufacturing. Our quest towards a brighter future has just begun, but with each step, we are closer to achieving our vision of a world less dependent on fossil-based plastics. As we stand before the horizon of possibility, we are driven by the promise of a better tomorrow.
Thank you. Thank you for the video. This looks like a very complex project. And we wanted to ask you, what was the most exciting step in working on this project?
First of all, I would like to say a thank you and good morning. We're grateful to be here from Kazinci Ferenc Gymnasium and Mobilis from Győr, Hungary. The most interesting part for me, and I think I can say for us, was to see how just by changing the formula a bit, so the alteration of the ratios of some additives would influence the final properties of our product. So, you know, all of our plastics are basically derived from starch and cellulose, and by the alteration of we added acetic acid and softening agents, we would then were able to make plastics with various properties which would be ideal for various applications. Some were more robust and strong, some were more flexible. So I think, as for me, I don't know about my colleagues here. I think that was it, yes.
Thank you so much. And after this experience with bioplastics, are you still able to use the standard plastics in your daily life, or how you now perceive this?
Well, I think this is an interesting question, and I find bioplastics really interesting, but there are still steps to be taken. Just like I've mentioned in the video, I still think that we need to find some, we need to research this topic more before we could move on to manufacture everyday items from this. So of course, there aren't really any things made from bioplastics in our stores in Hungary, as far as we know it. So I think for the time being, regular plastics will remain, but it's definitely an area that should be explored.
Thank you very much. Thank you so much for joining us. And now I think we can invite the next team. And the next team is from Bosnia, from Banja Luka. So I believe these are 3 high schools, if I'm right. So one from Banja Luka, medical high school, the high school, and Gradiška Gymnasium. I hope I cover it all.
How many schools you are representing? 3 schools, okay, from Bosnia. Okay, now let's see the video.
In the quest for innovative treatments, we meet 3 dedicated researchers, each playing a crucial role. Meet Danilo, Anja and Katarina. Zeolite, a natural mineral, is a versatile wonder with unique properties.
Zeolite's exceptional porosity, molecular sieve abilities, and diverse applications make it a treasure.
Today, we are here in Snjegotina, in Bosnia and Herzegovina, a treasure trove of zeolite. Our abundant zeolite reserves hold the promise of better drug delivery.
While the Snjegotina deposits remain to be exploited, our country is pioneering in the export of artificial zeolite.
Bosnia and Herzegovina is the #1 in the world when it comes to producing this precious mineral. The answers to many problems usually appear in unexpected things.
We all know that aluminosilicate zeolite can be used for manufacturing astronaut gear, environmental cleanup, but where else?
It might surprise you, but zeolite plays a crucial role in medicine, particularly in its connection to cancer patients and the use of cytostatics as an effective yet consequence-laden treatment. It's a truly intriguing link.
How? Well, it's because this material has a very high specific surface area. The value can reach several hundred square meters. In its pores, different molecules can be attached and transported into almost all parts of the body.
Understanding these interactions is a key to drug delivery innovations.
In the study, the used zeolite is clinoptilelite zeolite to enhance drug delivery.
Zeolite acts as a carrier, allowing the drugs to be absorbed into the body and directed towards the cancer cells. It increases the absorption rates by nearly 30%.
The research shows that zeolite accelerates drug dissolution in the body, promising quicker relief. Here, from Earth's violent and hot depths, a material with transformative powers is formed. Zeolite is a mineral, well known even during the ancient Greek and Roman times. Its name even originates from the words zeo, meaning to boil, and lithos, meaning stone. But the name was first coined in 1756 by a scientist who observed a material which released steam when heated from the water absorbed earlier.
Our scientists represent hope, harnessing the treasure of zeolite from Bosnia and Herzegovina for a brighter future in healthcare.
Okay, it looks like zeolite, the material of the future. And my question would be, so why did you call your video, the zeolite, the hidden warrior?
So we call this presentation a hidden warrior because it is not fully exploited in our country and it is underestimated. And we hope in any time soon it will reach its full potential.
Perfect. And I know there are two types of zeolite, natural and synthetic. Would you be able to answer what is the difference?
The artificial one, the synthetic, is made from mined bauxite, and we have a real big factory, one of the biggest in Europe actually, called Alumina. And the natural zeolite is found in natural open mines in Bosnia.
Great, and maybe one more question. We've seen that zeolite is a lot used in medicine. Are there any other potential uses of zeolite in the industry or in our daily lives?
Well, yes, of course. Zeolite is a very versatile material. Mainly, there is some research going on about it being used in astronaut gear. It can be used in a lot of different things, but mainly it's used in detergents for washing our clothes. So if Alumina stops producing zeolite, the artificial one, we would all have smelly clothes. So that would be pretty bad.
Thank you very much. Thank you.
Okay, thank you so much. Now it's time to invite here the class from Istituto Ghini, the class, the fifth here from Imola. We have the group or no? Yes? Okay, come, please. Because we are calling you and nobody move a muscle, no? And say, but okay, perfect.
We are the class 5AA from the Technical Institute Luca Ghini in Imola. Our project started in 2021 with a lecture on electromagnetism and renewable energy that led us to construct a windmill with the objective of educating people on the subject. The first phase of the construction of the turbine was about organizing the material and thinking about how to continue with the project. We then proceeded by tracing the cutting lines on some PVC pipes, which we could later use as blades for the turbine. Subsequently, we built a magnetic rotor, which is composed of one wooden support and 10 magnets. It has to be sturdy enough to hold the blades. Then we inserted the magnets inside the holes and secured them with the help of some glue. Later on, we constructed the stator, which is composed of 10 coils that overlap the rubber magnets. Then we verified that the dynamo produced current. This is how we planned and completed our project, which involved building a wind turbine last year and connecting an electrical circuit to it this year so that it can charge a phone. The regulator is a circuit that transforms in a continuous voltage of 5 volts, alternating voltage output to the dynamo, which will vary both in frequency and width depending on the speed of rotation of the blades. This will happen if the dynamo provides a voltage that falls within the limits of the regulator. But let's see this process in detail. The alternating current generated from the dynamo is converted to the required direct current. This is done by using 4 diodes. After the conversion, this signal is now passed through the electronic capacitor for filtering. The filtered signal is now sent to the voltage regulator. This circuit will give us our desired output of regulated 5 volts. Before going into the electronic device, we will filter the output one more time with a capacitor to cancel any residual noise. They can now charge various electronics devices such as smartphones, MP3 players, GPSs, and cameras.
Please come here. Yes. So, you worked 2 years on this project, you know? So they build up this huge wind turbine. So what was the most challenging part of this project?
Well, it was certainly in the second year when we had to understand what pieces to use and where to put them into the electric circuit. But we worked together as a team and we learned from each other and we did it.
Yeah, in fact, now you can also recharge your mobile, no? Yeah. With the wind turbine, so very, very useful, no? And you are at the last year of your school period, no? So are you already thinking about your future? Did you have already chosen something?
I want to do University of Biology in Bologna. You?
I have no idea. I think I want to do university, med university.
Me too.
Like me too. Okay, the same. Okay, so thanks for all your effort. Thanks for the effort of your teachers, and thank you. Okay.
Italy again. So let's invite another school from Italy, if I'm not... No, sorry, my mistake. Let's invite Otaniemi High School from Finland now.
Hello and welcome to Otaniemi Upper Secondary School. We will present our research project on SCOBY material and its possible uses. And here is our team, Ida, Sie, Laura, Beata and Elina. We all know plastic causes a lot of the world's pollution and it's made from a fossil fuel, oil, which causes greenhouse gas emissions. Also, only 9% of the produced plastic is recycled. In addition, the production of leather isn't always ethical, and it uses a lot of harmful chemicals that can destroy nature. Luckily, SCOBY material can be a solution to these problems. SCOBY is short for a symbiotic culture of bacteria and yeast, and it consists mainly of cellulose nanofibers. We wanted to see the different properties that dried SCOBY materials would have, so we started off by growing our own materials with varying ingredients. We made green tea and mixed sugar, kombucha and yeast with it. We then poured the mixtures into containers and added the SCOBY mother. We let them grow for about 3 to 4 weeks. After that, we let them dry for a few days, and here's the product. SCOBY material is a versatile biomaterial that can be used as a substitute for plastic and leather. It's light, resilient and dyeable. SCOBY material can even be made waterproof by modifying its chemical structure. SCOBY material can be used in clothing, fishing, decorating, packaging, and cooking. It has been found to have many health benefits like improving gut health. Example uses could be shoes, jackets, fishing nets, packaging films, biodegradable confetti, and balloons. By making products out of SCOBY material instead of leather or plastic, we could reduce the impact that we have on the environment. We hope that SCOBY material products will become available for all in order for us to live more sustainably.
Welcome. Another very interesting project. Now, what was the main, from whom came the main idea? Why you picked this topic?
So we had a course in school, a chemistry course where we had to do our own research. And then we thought about making something about a biomaterial. And one of our group members found that some people had made a SCOBY material and thought about it for like clothing, and we wanted to see how we could modify by the different ingredients, what kind of properties that SCOBYs would have.
Thank you. And were there any surprises within the project? Was there something that you wouldn't expect and you came across during the project?
Well, we already thought we could make it waterproof, and we thought about oiling the SCOBY material. It maybe would change its waterproof, but we didn't actually get that to work. So maybe that was the biggest surprise.
Thank you. This is obvious that this project needs to be very long-term to test it actually in many phases. Thank you so much for joining us. Thank you. And I guess the next team is from Greece, if I'm not mistaken. So let me invite the Ionios School from Athens.
Hi, I'm Elizabeth.
And I'm Irene.
We created the quiz and we designed the poster for the project.
We collected information and were responsible for the technical part.
Hi, I'm Panos. I'm George. And I'm Ekteras. We made the music for this project.
Hello, I'm Sophia.
I'm Despina.
I am Nick.
And we collected information from internet resources about raw materials and renewable energy.
Hi, my name is Nick. I was the main constructor of the design concerning renewable energy resources.
Come on. I think with this video you actually tackled the point that all the politicians are now talking about the importance of metals and minerals for the green technology. So was that anything surprising for you, or do you think, what is the actual importance of the materials for the green technologies? Any volunteer?
With the raw materials, we construct wind turbines, solar panels, and all of that. And at the end, green energy isn't so green because we destroy a little bit of the environment, and yeah.
It's not easy at all because, you know, even for this windmills and solar panels you need materials, but there is a need to find the right balance in between using the fossil fuels and the renewable energy. And I think Europe should be a leader. So thank you very much for this project. I believe that was very interesting. Thank you.
Okay, now. Okay, now it's time for another Italian school, Liceo Romagnosi di Parma. So please come here close to the only two, okay, and the rest of the class.
Why did we participate in this project?
E-waste, or WEEE, waste of electric and electronic equipment, consists in the waste of objects that contain highly dangerous substances for humans and the environment, as well as raw and valuable materials. Hence, it is essential to manage these projects consciously and sustainably in order to recycle and reuse them. These are the key points of the circular economy, which aims to revolutionize the current economic model, the linear economy. In fact, the model in use now does not take into account the act of recycling, resulting in a great long-term impact on the whole world. Circular economy is both a more sustainable and ethical model. By recycling objects in order to reuse the needed parts, there would be a decrease in the waste of minerals, which are mined along with the useful ones, and also a resizing of the human exploitation when mining.
How did we achieve our goals?
The first thing we did was to clarify what our goals were. We certainly wanted to make people aware of the risks that WEEE entailed and how important recycling is. Given the fact that it's a subject unknown by the majority of people, in order to engage as many people as possible, we decided to organize a collection of electrical and electronic waste in our school to start our recycling mission. We started an awareness campaign about WEEE and advertised it around our school and the ones in the nearby area, promoting our collection plan using posters, emails, and announcements. Since our school was planning to organize an assembly on Earth's Day, we jumped on the opportunity of promoting further our campaign by organizing a stand where people from different schools stopped by to recycle electrical waste, while also learning about the matter even more. From that day on, we left a collection point in every classroom so that people could continue leaving their devices. We concluded the project at our last assembly, where we invited an expert in regenerative economic approach to tell us more about electrical waste, recycling, and its link with circular economy, explaining the future impacts it could have if we don't change our behaviors now.
What were the final results?
The project lasted 4 months and it was a success. All the schools involved participated actively thanks to the promotion campaign. This let us raise an amount of waste, helping the humans and the planet. The amount collected on the 22nd of April's assembly consisted of 174.8 kilograms, divided into TVs, devices, computers, home appliances, and wires. The amount of the school collection consisted of 173.55 kilograms, divided into TVs, devices, computers, home appliances, and wires. We want to make this project a reality in our school.
It doesn't work? No, now work? Okay, perfect. Okay. So this class organized a large collection of we. But before the collection, also a campaign for raising the importance of we. So how did you organize your work? Yeah?
Okay, so we with socials and in our school, with emails and with the help of our teachers, we try to tell people of our school, but also people, young people of Parma, our city, about what WEEE are and how important it is to collect them and recycle them. And then we started organizing the collection, the real collection, that was put on with in occasion of the Earth Day. There was a big thing in Parma for the Earth Day. And so we actually were able to collect many WEEE.
Did you were surprised about the result? No, because I think you have collected a lot of quantity, high quantity, or no?
Yeah, we didn't expect this at all, because we thought that it was something that wasn't getting the attention that it deserved. But I don't know, maybe thanks to our campaign, partly, we managed to collect a lot of WEEs. So it was definitely a success.
Okay. Do you want to say something here? No, because usually the people speak only close to me. So now I change my position. And okay, do you want to share some comments, something that was a surprise for you, something that you learned in this project? Here? No? No, nobody? Here? Do you want to share a comment? How was this experience? It was so difficult, or maybe, I don't know. I don't want to suggest the answer.
Yeah, we had some difficulties, of course, but overall it was a really great experience for, I think, all of us. And yeah, I mean, also in the last part of the project, we had some difficulties with making the video and stuff, but the campaign in itself was not so difficult, so yeah.
But also the answer of your friends or of the other student of school was really impressive, no? So I think young people is sensitive to this topic, no? More maybe than what we are thinking about, no? So very good. This is an inspiration project. Thanks for your effort. Thanks to your school. Okay.
Now we would like to invite the team from Austria, from Europa Gymnasium from Leoben. So if the students from Leoben can join us, meanwhile we will show their video.
So, ladies and gentlemen, we, Marianna, Lena, Yannick and Jakob, want to present our project, Recycling Waste Aluminium into a Useful Chemical, potash alum. But first, let me start by giving you some background information. Beverage containers are increasingly composed of aluminium cans. In Austria, around 800 million cans are sold every year, and the Austrian company Red Bull, for example, sells around 7 billion cans per year worldwide. Though it is so commonly used, it has its disadvantages. The major source for the extraction is the ore bauxite, a mixture of different metallic oxides. Bauxite mines are systematically exploited. Then, aluminium is one of the most indestructible materials, and it takes around 200 years to decompose. Furthermore, the toxic alkaline byproduct red mud emerges. And lastly, the production is highly energy intensive. The electrolytic process runs at low voltage, but it needs more than 100,000 ampere.
Recycling aluminium uses 95% less energy than producing it from raw materials. Our idea, instead of recycling it into new metal cans, was to transform scrap aluminium into a new chemical compound, which is potassium alum, or short, potash alum. It's used for tanning and dyeing of fabrics, in cosmetics or as an astringent to stop bleeding, for water purification, or for growing crystals in science kits. But how can you convert aluminum metal into a salt? This reaction involves two major steps. The first is the oxidation of the metal. Aluminium is protected by a thin layer of aluminium oxide. Strong aqueous bases dissolve this oxide layer and then attack the metal, as you can see here. Hydrogen gas is also formed, which is very explosive. Here we demonstrate it. The second step is the formation of the salt potassium alum when strong sulfuric acid is added. The expected theoretical yield of potash alum when using 1 gram of aluminium is 17.5 grams.
Now we want to show you the procedure step by step. Using sandpaper, we scraped off any paint of the can. With scissors, we cut 1 gram of the aluminium can into small pieces to get a faster reaction later. Then we dissolved them in potassium hydroxide. To speed up the reaction, we heated the solution. Hydrogen gas was generated, which we carried away by the suction of the fume hood. The colorless mixture turned dark gray. The reaction was complete when the hydrogen evolution ceased. Then we filtered the hot mixture to remove any solid residue. The filtrate was clear. In the filter we discovered pieces of plastic. Therefore we knew that the inner side of the can was coated with a thin plastic layer. We analyzed the brown residue and detected iron ions.
To get a salt, we slowly and carefully added half-concentrated sulfuric acid to the cooled solution, which got hot again from the neutralization reaction. White aluminium hydroxide precipitated, which completely dissolved again after we added more sulfuric acid. Then we chilled the hot solution in an ice water bath to enable the crystallization of potash alum from the supersaturated solution. We induced crystallization by scratching the inner walls of the beaker with a glass rod. Then we filtered the crystals in a vacuum filtration apparatus, rinsed them in ethanol and let them dry. We synthesized 11.8 grams of potash alum, which represents 67% of the theoretical yield. Lastly, we wanted to know if our salt is suitable for growing crystals in science kits. Here you can see our results. If you have any questions about the project, please contact us.
Welcome. Now, my question would be, what was your motivation to pick this topic for your project?
Well, young people often consume their drinks out of aluminium cans, and other than plastic bottles, it's quite unclear what happens to the cans after usage. So that's what we wanted to find out. We wanted to find out what actually happens after the cans are used and what can be done to improve the recycling process.
Thanks. And after this project, did you change your consumer behavior or? Yep.
Well, I was pretty shocked to see the numbers of the aluminum cans that are produced in Austria, and I think all of us are also buying a lot of aluminum cans in energy drinks, and I will definitely try to buy less aluminum cans now.
Great. Thanks a lot. Thank you very much for this project.
Okay, now it's time of the team from Majorana High School, from San Lazzaro di Savona, Bologna, okay? And they work about a project on phosphorus.
We are here to present our project. Who Won't Save the World is the title of our board game, and we are sure that its meaning is not as fairy as you could probably think.
Since our first year of high school, each teacher has sensitized us about environment issues, like the phosphorus cycle, that's very important for growing our plants, or the transformation of food into energy. Finally, with this project, we have been able to raise awareness in this regard, with the main focus to expand the target to every kind of person. So, how it all began? To quote Martin Luther King, he will say, "I have a dream." Well, I had a dream. 4 months ago, while I was sleeping, I had a revelation. An idea of a board game appeared to me, and I silently turned the dream into reality. As we wanted, this game is for everyone. Like I said before, the age range is from 6 to 99. You might think that you need some information about biology or phosphorus. Well, don't worry, we also thought about this. Actually, our game is targeted at those who are not in this business. As a matter of fact, you will learn everything you need to enjoy just learning by playing.
The game was designed for 3 to 4 players, and everything revolves around one of them, the villain. The villain represents the man who just wants to make money through investments in polluting factories, not caring about the environmental footprint. The other players have to team up in order to defeat the villain and save the world. In addition to the character cards, which only describe each role of the player, there are 3 types of game cards: Factory, System and Action. One of the most important components of the game is the phosphorus wheel, representing the rate of phosphorus wastage. The wheel is split in 2 around the half. Maybe now you are wondering how does the game proceed? Well, the good guys battle to reduce the phosphorus waste to 0%, while the villain fights to increase it to 100%. At the moment someone completes this quest, the game is over. Our game is also based on real life. We use data information about real factories and real systems. Nowadays, the rate of phosphorus wastage is higher than 50%. How can you know this and much more? Well, you can find some real methods in every single factory and system card that we call peers. That is the reason for the first phrase. The title is not airy fairy.
Come with me, the center of the stage. Okay, so you develop a game, okay? Did you test the game? Yes?
Yes, of course. We thought about every kind of development. We focused on a mathematical approach for our board game, and we also found some difficulties, like the printing itself. We didn't expect it to be so difficult.
Yeah, in fact, developing an educational game is not an easy task, because the game should be something to have fun, but also mainly for learning something. So, but do you think that could be could be good to use the educational games at school during the official programs. What do you think about this idea?
Yes, we do. I think it is a great way of learning. As a matter of fact, we've already involved the younger class of our school in it. By the way, we want to thank our classmates and the 4M of our same school because we couldn't be here without them. Now, another thing is that we want to pleasure to all of your project. They were unbelievable, I think. But I swear you that our board game is way better than our project, than our video.
So you have a stand now in the exhibit, 2 stands, okay? So we can invite them to test, to play the game, no? After lunch, if you want to play the game, these guys have a stand, okay? Do you want to add something more? Yeah?
We want to invite all of you because our game is thought on learning by playing. So you just have to come and play with us because only you are missing.
I did another work with 2 classmates. Is a short questionnaire about phosphorus. You can come visit our stand and try this questionnaire. It's only 15 questions. It's very short and fast. See you there.
Yeah, I know that you work a lot. Also, you collect a lot of answers. So here, actually, we presented only one of the product realized by these classes, but they work hard and they prepare a lot of things. So please go and visit their stands, okay? Thank you.
Thank you very much. And before the break, we will still invite one school. This time it's a high school, Filipa de Lancastre from Lisbon, from Portugal. So please join us on the stage.
Glass is a material universally used in a variety of different fields due to its various properties. We see it every day, from the construction industry to its use in jewelry and even furniture. Glass's properties make it an essential material in our modern society. But how often do we stop to consider the way it's made? Glass's main component is silica, which is a chemical compound common in rocks and sand. By melting the sand and then cooling it quickly, thereby avoiding unwanted crystallization, silica forms an amorphous substance that gives glass its transparency and properties. Silica, however, has a fusion point of about 1714 degrees Celsius, which are temperatures that are extremely hard to reach.
To lower silica's fusion point, substances like quartz, samphire, and fern ashes would be mixed in with the sand. This brings the fusion point down to 750 degrees Celsius, a temperature much easier to reach. After fusing this mixture, the Egyptians would shape them into lingots and would later melt them again, molding them into their desired shape.
With access to modern methods, reaching the high temperatures required to fuse silica is much easier. Still, there are a variety of different substances that are used nowadays to alter the properties of the glass, like its color, opacity, or resistance.
For instance, there are a variety of metals that can be added in powder form to change the color of glass. Iron, for instance, makes the glass a green color, while copper and cobalt make it light blue and dark blue, respectively. But there are still a lot of different metals that can be used to create a variety of other shades. Glass also possesses a series of other properties that make it very useful. It is very chemically resistant, making it a material of choice in the fabrication of many of the lab supplies we are familiar with. Glass's impermeability also allows it to be used in the making of toilets, as it protects the porcelain underneath.
From its ancient origins to its modern industrial production, glassmaking has evolved into a complex and precise process. Glass is used every day, and without it, science would never have reached as far as it has nowadays, making it an extremely important material worth appreciating and learning more about.
Thank you. My obvious question will be why you pick glassmaking as the main theme of your project?
So we wanted to talk about a product that was common but had some history, and glass. We found out that glass has been made long before we had the capabilities to do it easily like we do today. So we decided to do our research and learn and figure out how the Egyptians, like we showed in the video, were able to make glass without being able to reach the temperatures we can reach today, using the same materials, etc.
And were there any interesting discoveries or unexpected discoveries for you?
I think I speak for everyone in the group when I say like I had no idea how glass was made, and I had no idea that ancient Egyptians did it. So I think I learned a lot, actually, and also about the fact that we mix different elements with the glass to make different colors. I think that was pretty interesting.
Yes, indeed. And I think the animation process of your video is also super and very well done. So thank you very much for this video. Thank you. Now, before the break, we would like to ask you to make a family photo, which means somehow all of us should fit in, which is not an easy task. So I would like to ask you to squeeze a little bit to the middle, to stand up and move into the middle of the room.
Okay, take the flags.
And please take the flags, the national flags with you. We will ask you to show the flag.
Okay. In the meantime, I want to tell you something about the coffee break. The coffee break for the student will be out of this conference hall. For the teacher and partners, there is another coffee break in the rooms behind the stage. Okay, now we have the break. Okay, half an hour of break, 30 minutes. 30 minutes, okay, go and have pizza. Okay.
can I have your attention for 1 minute? Can you please sit down so we can start with the second part of this morning session? Please take your seat.
Please, one moment. Okay, of silence.
Thank you, Armida. So, okay, thank you. This afternoon, after lunch, after this morning session, as you may know, there are several workshops that will be offered to all students who want to participate. They need to register for these workshops at the entrance. So please, if you haven't done it yet, go and register, because there are limited numbers. And the activities are reported in the leaflet, but some of them will be held here, and some are in the upstairs. So, in the meantime, during the workshop, there will be also a series of seminars that will be held here in the main conference hall. It's free for entrance. Everybody can come in and do not need to register. That's all. And also, I want to remind you that at the desk at the entrance, you can find a short description of what is presented in the different stands that are in the central hall. So if you go there, you can pick one of these lists, and you have a rough idea what is presented, so you know what you are going to see. So now I leave you to the second half of the morning session, and I hope you enjoy it. Ciao.
Okay, I think we are all again together in the conference hall, so we can start again. So, did you have a break? Did you eat pizza? Eh? Okay, I hope it was enough. Okay. Yes. So now we start again, and it is the time for the team from Germany. Okay, I'm not able to read the name of the school, sorry. So please come. Okay. Okay. So, I'm a little bit curious now. So, do you have any idea how to develop your program, your project? Do you have some plan for maybe for your shipping box?
Yeah, so we have like the idea, we have a lot of options to improve it, and one idea is that we make really all of the parts are made out of bio-based plastic. So also the parts where we connect the sides of the boxes. And another idea is to make the padding material inside the boxes also exchange it from plastic to like paper and save space and make it more good for the environment and something like that.
And how long did you take? How long did you spend in this project, in developing this project?
Yeah, so it took the longest to get the idea to what to do because it's a little bit difficult to have an idea what you want to do and then actually working on it and finding out how efficient it is. It was also a little bit difficult, but I think overall it took like 2 months or something. Yes.
I think also 2 months, it's also maybe not so long time for what you try to develop now, because also I suppose that you have also to find information. And so did you form groups or, how did you organize your work?
Yeah, we have groups of 4 or 5 in our class, and then we thought about what is better for the environment, what we can make for it. Yeah, and then we tried to produce it.
Okay, thank you. It was a great idea. Thank you so much for your effort.
Okay. Now, we will invite the next group of students, and we go again back to Italy. And I would like to invite students from the Institute Sobrero, Casale Monferrato, to join us. And here is their video.
Hi everybody, my name is Davide, and I'll be presenting you the game my friends and I from Sobrero High School in Casale Monferrato, Italy, created for this amazing project, RM Taboo. So, it's a game with the aim of getting to know raw materials in an enjoyable way. For example, you'll learn what are raw materials, why they are so relevant, where they can be found, and why it is so important to recycle them. The rules are very simple. First of all, each team takes turns drawing a card from the deck, on which there are the word to guess, 4 forbidden words, and a short description, including some interesting facts of the term. The player reading the card has to help his teammates guess the word without saying the taboo words. The board includes 17 normal squares, 5 time double squares, 2 stop squares, and 3 super squares. If the team lands on one of the super squares, they have to throw a special dice. The first team to reach the last square wins the game. The game has been fully realized by us. We have designed the graphics of the cards and of the board. We created the pawns, and we adapted the rules to make it more interesting. We are honored to be able to present our game to you today, and we hope you will enjoy it as much as we do. Thank you for your attention. Have fun!
It's a big team. So I guess my first question will be, you know, how you managed to coordinate all of you to work on this project. So who was the leader and who came with the idea of the board game?
So our teacher suggested that we created a game in order to teach younger students about everything related to chemistry and raw materials. So we are from 2 different classes of the same school, and we practically divided the works, and somebody designed the graphics and he designed the video. And that's it.
That's great. And how long did it take you? How long you actually work on this process? And did you have a chance already to test it with the younger students?
Yeah, we went to a school in our city, and we did a little game with younger students, and it took about 1 month to create all this. We used all machines that are in our school.
Perfect. And a very last question, what was the feedback from the young kids?
They obviously enjoyed it, and I hope they understand something.
That's great. So now we can hope that this can be spread, possibly at least all over Italy, to land younger students. Thank you very much.
Thank you.
Now, let's invite the next school, and we will now invite the second team from Hungary, and it's a Pécsi Gyakorló Gymnasium. I hope I pronounced it right. So the high school from Pécs, if you can join us here on the podium.
Hey everyone! We are the team from Pécs, Hungary.
And in this short video, we would like to present our project CMA. Our main goal was to find a way to make use of the mining byproduct in Kővágó-Szőlős. Kővágó-Szőlős iron ore is located in the West Magic area, which they mine from the green sandstone. In the late mine, a slurry treatment plant is still in operation, where they get rid of the water's uranium content. This results in high salt concentration in the water, which they precipitate with lime. The generated precipitation is snow white, and based on X-ray diffraction, its composition is mainly magnesium hydroxide. It has been deposited as industrial waste on the waste heap until now, but it has been recently found that this sludge is ideal to produce calcium magnesium acetate, aka CMA. There are soil and gamma spectrometric measurements carried out regularly. The results are always well below the limit, so CMA's only limitation is its production and distribution costs. We would like to present the possibility to use CMA as a great alternative regarding root de-icing and slip resistance, as it is very incorporated into the soil structures, thus even improving the soil quality. Furthermore, we would like to promote the use of CMA as a dust binding and adhesion enhancing material.
The production of CMA can be conducted under ordinary conditions, although with a rather low efficiency. We focused on determining which of the raw materials is the most suitable for industrial CMA production. We compared 3 collected samples, one of which was the raw limestone milk from the said waste heap. During our experiment, we reacted all 3 samples with 30% household acetic acid in a 1:1 ratio. The mixtures were stirred using a magnetic stirrer until the indicator paper showed neutral acidity. Afterwards, we filtered the mixtures through filter paper, and the remaining solution only contained water and CMA. From these solutions, we crystallized the CMA and measured the composition. It became obvious that the 2 samples from Kővágó-Szőlős surpassed the dolomite limestone dust by far. With another experiment, we demonstrated the de-icing ability of CMA with 3 ice cubes, one used as a reference, another sprinkled with salt, and a third with our produced CMA. The salted ice started melting first, and not much after, the CMA one followed, and several minutes later came the control ice. So in conclusion, it can be said that CMA is similar to road salt in terms of de-icing efficiency. In case of their impact on our infrastructure environment, however, they are far from being alike. To showcase this, we put CMA in one beaker and saline solution into another, and we placed 1 iron nail into each. We let them sit in their solution for 3 weeks, and after we compared them. It was clear that the nail in the salt water got rusty, while the other remained the same. This proves our claim that CMA is a gentler de-icing agent than salt.
In the future, we'd like to try to produce CMA from other magnesium, calcium-containing materials. Also, we plan to test CMA as a dust-binding agent in a still-functioning mine. All in all, we want to promote the usage of CMA instead of other de-icing agents.
Thank you for the video. So now my question, what was the most exciting part of the project?
I would say that going to the mine and collecting the samples was the greatest part of it. And also...
Sorry.
No, that wasn't your fault. Sorry. Also, being in a laboratory is always great for us, so it was all in all a very good experience.
Yeah, the practical experience is always something that is amazing, right? Is there some lessons learned from the project? Is there something that you would like to highlight towards our audience that you think is really great?
Well, we had to plan the experiment, and in the beginning it wasn't as planned as we thought it was. So in the beginning there were many failed attempts, but after a while we corrected each and every mistake, and then we could produce the CME finally.
I think this is very often the case in science, right? That you have to find the right way. So thank you very much. Thank you for joining.
Okay, now is the time for Istituto Facchinetti Castellanza Varese. We have here two delegates of the school.
Hi everyone, we are two students from Mrs. Facchinetti in Castellanza. My name is Riccardo Mancuso. And I am Macri Manu. Today we're talking about cobalt. What is cobalt? Cobalt is a fascinating transition metal with unique characteristics, and it plays a crucial role in modern technology. One of its standout features is its ability to form magnetic alloys, making it essential for various applications like wind generator and electric motors.
Cobalt is also a key component in lithium-ion batteries, which power our cell phones and electric vehicles. However, this growing demand for cobalt has raised concern about its environmental impact. Cobalt extraction can lead to ecosystem destruction and groundwater pollution, particularly in developing countries with lax environmental regulation.
Not only that, there are troubling reports of exploitation and child labor in cobalt mines. To ensure a sustainable and ethical cobalt industry, it's vital to promote responsible practices that minimize environmental harm and protect the rights of workers.
In summary, cobalt's role in technology is undeniable, but we must be mindful of the environmental and ethical implications associated with its production.
It's a delicate balance to strike. We rely on cobalt for these critical technologies, but we must also ensure that it doesn't come at the cost of our planets and human rights.
Absolutely. It's about finding innovative ways to meet our technological needs while respecting the environment and workers' well-being. Responsibly, cobalt is the way forward.
Thank you for the attention and see ya!
Welcome. I think my first question will be quite obvious. Why cobalt?
Because cobalt is the principal material that is used in our cell phones, and this thing touched me personally because many children are exploited in this process of mine cobalt. That's why we choose cobalt.
Yes, that is very controversial theme, right? When getting cobalt. So, were there any difficulties that you faced during the project?
Especially one thing that is the main difficulty is making it a video, because the main topic is cobalt, but is a really characteristic material. That's why we think that we need to explain it really well. That's why.
And this is another thing that scientists are very often facing, that, you know, the actual invention or the project is one thing, but then to sell it to the outside world is another thing. So thank you very much for spending the time and the effort on making the video. Thank you. And now we will actually invite the local team, right? Is that correct? So let me invite the Liceo Combernico from Bologna.
Viene messo in evidenza, non è tanto il principio attivo che manca, ma mancano le materie prime. Dal ferro al palladio, dai RAE, una soluzione a carenza di materie prime. Ricerca targata Ambrosetti e Rion stima a 564 miliardi il valore della produzione a rischio. Economia circolare, risposta alle carenze di materie prime.
Quanti problemi? Sì, dovremmo iniziare ad adottare i medi estremi, dovremmo stravolgere la nostra vita per rendere la nostra permanenza sulla Terra infinita.
In questo caso ci potrebbe salvare l'economia circolare, perché ricorda, niente da buttare.
Utilizzare, riciclare, ridurre, risparmiamo un po' di rame per condurre.
Il prezzo è alto ma la pera non ha prezzo, solo noi possiamo fare la differenza. Ed è appunto grazie a questo processo che la filiera possono avere più successo. Basta consapevolezza e un po' di esperienza, le materie prime rare cerchiamo di salvare. Metalli rari, preziosi come l'oro in oggetti che gettiamo via. Prezzo è alto ma la terra non ha prezzo, solo noi possiamo fare la differenza. Ed è appunto grazie a questo processo che la filiera possono avere più successo. Basta avere consapevolezza e un po' di esperienza, le materie prime rare cerchiamo di salvare. Metalli rari, preziosi come l'oro in oggetti che gettiamo via. Nascosti in bella vista sì, come la Cina, che di elementi a rischio ne ha ben più di una decina. Il problema reale non è nemmeno questo, il problema è che pensiamo al futuro, non ad adesso. Dobbiamo pensare alla difficoltà d'estrazione e pare proprio che non ci sia una soluzione. Una cosa è sicura, non ha senso usare energie che non si possono più riutilizzare. Prezzo è alto ma la terra non ha prezzo, solo noi possiamo fare la differenza. Ed è appunto grazie a questo processo che la filiera possono avere più successo. Basta avere consapevolezza e un po' di esperienza, le materie prime rare cerchiamo di salvare. Metalli rari, preziosi come l'oro e oggetti che gettiamo via. Siamo tutti chiamati ad agire per un futuro migliore da costruire.
Please come. So you are really a very creative class, eh? Okay, come here. Yeah? Okay. We have space for all? Yes, okay. So how did you get inspired for realizing this project?
We participated to a lecture about raw materials held here. The concept for the video clip came by the various suggestions from everybody. And the various suggestions were about doing videos around the school premises and doing a song. So we crafted this video clip you just witnessed.
If we have time, we want to repeat all the movement. So you were able to create the song by working all together, or no? Okay, or there was a team that had to find some info or some test. How did you organize? Yeah, I go again here.
With this project, we divided in different tasks, and
each task was accomplished by a group of our classmates. For example, our group was, his task was to do the lyrics for the song, and it was made by four musicians from our class, and also the choreography was made from 2 dancers.
You created the music and the dancers, the design. Okay, choreography. Okay, so after lunch, we want to see. No, okay. This group, we have to give a special applause to this group because also they are the team that support the organization today, and also they are available to support us in also offering the lunch and all the other things. So thanks also for this.
The subtitles the song was in Italian, but we made the subtitles in English so everybody can understand, and we tried as much as possible so they were in the rhythm of the song and also kind of rhyme, so it's like the original one in Italian.
Okay. Perfect. Thank you so much. Thank you also for your effort during the conference. Okay.
Okay. Let's invite the second team from Bosnia and Herzegovina. And this is the High School for Electronics Nikola Tesla from Banja Luka.
Graphene is a wonder material with many superlatives to its name. It is the thinnest known material in the universe and the strongest ever measured. There are 2 primary methods for producing graphene, bottom-up and top-down. Bottom-up techniques involve the gradual growth of graphene sheets on a copper plate, layer by layer. On the other hand, top-down methods use graphite, a rock composed of countless layers of graphene, which are then separated, or how we say it, exfoliated. One way is through chemical exfoliation that happens in high concentration of acids, which results in graphite oxide, graphene oxide, and ultimately reduced graphene oxide, RGO. One of the most fascinating methods is electrochemical exfoliation, where electric current drives ions between the layers, prompting the exfoliation of graphene. While some portions of graphene may flake, in this process they can easily be converted into single-layer, 2-layer, multi-layer, or nanoplate graphene flakes. These flakes impart graphene-like properties to materials.
Graphene's diverse properties have led to a broad spectrum of applications, spanning from healthcare to aerospace. It finds utility in fields such as sensors, biomedicine, composite materials, microelectronics. Applications include transparent conductive films, highly sensitive chemical sensors, and quantum dot devices. Most notably, it plays a key role in cutting-edge personal technologies. But why is it important for us?
We are now at the Stanari coal mine, which is also labeled the youngest thermal plant in Europe. Our country has deposits of over 1 billion tons of this raw material.
Both graphite and coal, being carbon-based, can serve the same purpose for obtaining graphene. We are proud to say that our compatriot, Professor Dusan Losic, was a pioneer in inventing and applying the method of electrochemical exfoliation to both of these materials. He continued his groundbreaking work at the University of Adelaide in Australia, and his research is now applied in the company First Graphene. It's important to note that this technique can also be applied to charcoal because of its similar graphene layer structure. With the European Green Deal emphasizing the reduction of coal usage, our vision is to transform our country into a European hub for graphene production, contributing to a more sustainable and environmentally friendly future. We invite you to join us in this exciting journey, C2G, towards innovation and sustainability.
Now, graphene is very often called a material of the future. So why is graphene so strong material?
So the first, it's important because of bonds between C atoms, and they have 4 covalence bonds, and 3 are between the C atoms, and the last one is free, so the graphene is better conductivity. He has better conductivity of electricity because of that.
Super. And how much graphene actually the industry needs? How much graphene we need as a society?
So with all this production and research going on, with the production of graphene, since it's a new material, only less than 1% of graphene needs are fulfilled now. So the amounts of graphene we need are really, really big.
And there is very often a confusion in between graphene and graphite. Could you explain the difference, that actually it's not the same?
So graphite, we can find graphite in nature. Graphite is actually an ore which we can mine, and graphene is actually one layer, one atom thick, and we can find it in nature. It's just made out of carbon atoms, and like we can say that graphite is actually many graphenes just sorted, like layered, how to say this? Yeah, stacked up together.
Super, thank you very much. That was a crash course, thank you. Now, let me invite now Latvia, the school, engineering high school from Riga. So let me invite the team from Latvia.
Hello, we are from Engineering High School of Riga Technical University, and we are representing Latvia. My name is Linards.
And I'm Igors.
And we want to present our scientific research work about improving the biodegradation of biological waste with microbiological fungi. Our main problem is the ever-increasing amount of produced waste. Bio-waste is a valuable but unused resource, which could be useful and good for the planet. Our solution to the problem is using fungal mycelium to speed up the composting process, reducing the bad odor and improving compost quality. We made experiments with cabbage bio-waste and different microbiological fungi from Latvian forests.
So here are the results from our 3-week experiment. The graph tells us that compost with fungi can induce carbohydrate concentrations even for 45% more than without fungi. That means that faster carbohydrate degradation to CO2 and water. In this graph, you can see that after 3 weeks of composting, the fungi adjusted pH levels and phosphate concentrations, which could be as good as a soil adjustment in agriculture. Also, fungi change the CN ratio, which is important for a good soil additive. And during the experiment, we noticed that there are fungi which can change the odor to a more pleasant one. To conclude, fungi could be potentially used for compost improvement in agriculture or in waste management to speed up the process and reduce the odor. Thank you for your attention, and if you have any questions, feel free to ask them during the poster session.
Welcome. My question would be, why did you use plant pathogen fungi for the bio-waste degradation?
So we used the pathogenic fungi just to compare it with the other fungi because of the known ability of the pathogenic fungi of growing fast, spread fast, and degrade biomass faster than the other fungi.
And could you tell us a little bit about the biggest difficulties during the project?
The biggest difficulties are probably maintaining the experiments clear, because fungi mycelium could spread to different bio-waste, and it's hard to keep bio-waste separate from different fungi, so experiments could be validated.
Thanks a lot. I think this is also one of up to university level projects, so thank you very much for joining. And let me invite the school from Spain, from Madrid, which is the Institute of Education, Secondary Education, Lázaro Cárdenas. So please, the students from Spain.
We are going to do an analysis of the hardness in the water. The concepts are 1. What's about, 2. Materials, 3. The process and the period, 4. The calculation, and 4. The conclusion. What is about? We make an assessment to estimate the hardness of the water by measuring in the concentration it has of a calcium and magnesium. Materials. We need a latex cloth, Erlenmeyer flask, burette, spatula, safety glasses, test tube, and lab coat.
For the first practice, let's determine the concentration of both ions, and then subtract the calcium results from these ones. First, we put 100 milliliters of water into an Erlenmeyer flask. Then, in a test tube, we introduce distilled water and pour it into the flask. Second, we add 2 to 5 milliliters of the pH buffer solution with a pipette and then mix it. Third, add a tip of a spatula of Eriochrome black tea into the Erlenmeyer flask. Fourth, we mix it until a light violet. Fifth, the ETA solution is poured drop by drop from the burette into the Erlenmeyer flask while constantly mixing the solution. Sixth, mix until it changes the color.
In the second practice, what we do is calculate the concentration of calcium, and in this case, the change is from pink to blue.
First, we put 100 milliliters of water into the Erlenmeyer flask. Then we add 2 to 5 milliliters of sodium hydroxide with the pipette and mix. Later, with the spatula, we add Morexit to it and mix. It will remain purple. From the burette, we add drop by drop, mixing continuously until it changes from violet to blue again. Finally, we write down the value given by the burette. Calculations. We know the data, which are 3.2 milliliters of EDTA, 6 milliliters of EDTA for the concentration of both, and 100 milliliters of water. We also know the EDTA molarity, that is 0.01. Then we have calculated the number of moles of calcium and magnesium. To finish the calculations, we have expressed the results in grams per liters.
To conclude the practice, after finding out the amounts of calcium and magnesium in the water, we observed that there is less calcium than magnesium.
Welcome. So most of us know that we need magnesium for our body because a lot of supplements are based on magnesium, especially when we are exercising hard. But why actually we need magnesium?
Because we need, because we know that it's important to regulate
it's important because it regulates our nervous system and the blood sugar level.
Yes, and it's actually avoid tiredness. So it's something when you are really tired, you need magnesium supplement. And was there something really surprising that you came across during the project?
I think the thing that surprised us the most has been how the has been how the mixture of these changed the color so quickly.
Super. We didn't want to stress you. Thank you very much for the project. Now, we will invite another group from Italy for a beautiful city, Ferrara, not far from here, Liceo Roiti.
In Italy, each high school participates in a project called PCTO, which consists of work-related learning. Due to this project, we went to the CNR headquarters in Bologna to attend a lesson on critical materials and circular economy. We also dedicated our time there to conduct experiments that easily and clearly show the reactive capacities of metals. After that, we were taken around the building for a tour so we could understand what is actually being done in the CNR. We saw all the various research, portals, and instruments used there. After this day, we could say we officially became participants of the Law Matters Ambassadors at Schools project. Our objective was to speak about redox reactions to elementary school children and have them do the same experiment we conducted. Thus began our training. We were invited again to the CNR to help the researchers with middle school students. We had them participate in interactive games meant to educate on the importance of recycling for material recovery, which is fundamental for environmental sustainability.
After the days at the CNR facility, we were then divided into 4 groups. Altogether, we prepared a site, different activities like Kahoot and CNR, and we also prepared 7 videos with various types that were meant to explain the basics of chemistry to the children. The videos that we recorded consisted of some short skits, several animated short films, and drawings that were explained through our solver. After all this work, the long-awaited day finally came, and we went to the elementary school ready to show what we prepared. We then actually started producing our videos and doing our activities, making sure the children understood what we taught them. We then moved on to the second half of the day, in which we executed the experiment we learned at CNR. After spending the day and having fun together with the children, we greeted them and left, hoping that they came at least a little bit closer to enjoying the beautiful world of chemistry.
Thanks to these 2 days and our prior in-depth preparation, 10 of us were chosen as ambassadors and we were given the opportunity to go to Banja Luka, Bosnia. By the end of August, we were ready to begin this journey. On the first day, we were welcomed by one of the Bosnian teachers who worked for the university we were going to visit. The next day started with a small competition between our group and 3 other Bosnian schools. Later that day, we presented one of the projects, piercing the aluminium without touching it. In the meantime, some of us were occupied showing some posters which were made to showcase the work we had previously done with children. The next morning, with a coach that drove us to the mine, there, an engineer was waiting for us. We spent the last day visiting different university departments, including the scientific quarters, where we had the opportunity to look around and talk with several researchers and students.
Thank you.
Okay, please come here. Okay, so you work a lot with CNR and here on this project, no? You develop a website, videos. You worked with elementary school. They helped us also during one event for the celebration of the birthday, no, of CNR, that this here have 100 here, no? So how was your experience in developing this project?
Well, good morning, everyone. It's really nice to be here. It's a really big opportunity, and we are grateful to have been invited for this program. It was a very wonderful and pleasurable experience because we had the opportunity to bring science out of our textbooks and we could actually do things practically. It wasn't really easy. Let's say the most difficult part was deciding how we interact with children, because it's not really easy when we talk to our peers. We can use all technical words that we want to use, but when we talk to little children that they don't know anything about science or chemistry, it wasn't really easy, so we had to dump it down a bit.
And also, you took part to the International Summer Camp in Bosnia, okay? So, if you have to say something about this experience, what do you think that was the most important things that you learned by participating to this kind of initiative in the summer camp?
So we discovered what they do in Bosnia to develop their country, even though they're not in Europe. And we didn't really do much, if not going to visit and exposing what our work was.
Okay. Anybody else want to add some comments? Yeah. I think you work a lot. I'm sure that you have a lot of problems to solve, but at the end, I think the result is really good. So congratulations and thanks again, okay, for your effort. Okay, thank you.
Thank you very much. Now, for the next two videos, we will move a little bit further north. The first video will be from the high school from Skellefteå, from Sweden. So please join us here.
Sustainable society demands metals. This applies not only to the recycling of old products, such as smartphones, but also to the technical development of new fossil-free energy sources. If the metals that we use for everyday products, such as our phones, TVs, or HDMI cables, come from recycled parts, we can drastically lower our carbon footprint. In the technical development of new fossil-free energy sources, metals are a must. And by using recycled metals instead of mined ones, we can start the green transition even before the new technologies have been created. In order for the green transition to take place, we need metals. And by making sure that the metals we use come from recycled parts as much as possible, we can reduce the number of metals that we need to mine. We're creating a recycling cycle, and this leads not only to smaller carbon emissions from the mining industry, but also to smaller emissions from the products which are created with those metals.
The city of Skellefteå has a long and profound history of mining industry. It has been known that our area is packed with ore and minerals ever since the 17th century, but in 1924, the prospectors made the biggest finding yet. A gold fever broke out when the workers found ore filled with large quantities of gold. A small piece of ore that left the ground on that special day is what laid the foundation of the modern mining industry that you can see to this day. Boliden Mineral AB was founded not long after the discoveries in 1931 and quickly wanted to begin to smelt the ore to extract minerals. Boliden wanted to do the job themselves instead of exporting it to other countries and decided to build a smelter a bit outside of Skellefteå. It was named Boliden Rönnskär after the location and has been up and running ever since the 30s.
In recent times, Rönnskär has evolved and become one of the world's largest recycler of electronic material. The Rönnskär smelter mainly focuses on the metals copper, lead, silver and gold. For example, producing copper with a high standard, almost reaching a purity of 100%. The same can be said about both silver and gold. They produce these metals from raw ore, but they also recycle electronic waste. From the nearly 18,000 kilos of gold produced by Boliden, about 28% of it comes from only recycling. That is 5,000 kilos of gold and solely from recycling. Boliden is also producing a fair amount of silver, close to 600,000 kilos, of which a fourth comes from over-recycling. Boliden's vision is to become the most climate-friendly and respected metal provider.
Thanks for listening.
Welcome. Sweden is very well known for its very high recycling rate. And Skellefteå is one of the best practice because owned by Boliden, this is one of the top recycling plants. So could I ask you, how was your cooperation with Boliden? Did you have a chance to visit the plant, and what is your impression?
Yes, so we visited a place called Rönnskär, which is where Boliden sends their metals to be recycled, the entire class. But this project in particular, we started about 2 months ago. So we actually haven't really worked with this so far. So our project starts now and we'll finish it as our final exam next year.
And since you will cooperate with the companies, and Boliden is obviously one of the really big companies in Sweden, would you consider in the future to work for such a company?
Yeah, I mean, they pay well, so I mean, yeah, I'd work there probably.
I think the other huge advantage is that they are really the top leaders in case of copper production, zinc, silver. So thank you very much. Thank you. All right, and as I said, we stay in the north because we will invite the Gustav Adolf Grammar School from Tallinn.
Hello everybody, we are Lisanna, Eleanor and Merilis from the Estonian team, and we will be introducing you to glauconite. But what even is glauconite? Well, glauconite is an undersized mineral resource found in multiple places around the world, including Estonia, Russia, Ukraine, Australia, North America, and many others. It is a sedimentary rock, meaning it formed underwater millions of years ago during the Cambrian and Ordovician age. Here you can see the chemical formula that consists of lots of different metals and elements. Mineral glauconite could be used as an eco-friendly alternative to traditional potassium fertilizers currently used in agriculture. It does not leave any harmful elements in the soil like chlorine and is able to release potassium during several agricultural seasons. Another really useful property of glauconite is the ability to filtrate heavy metals from water. Fun fact, it was also used in Russia for painting Orthodox icons. So, to raise knowledge about the potential of glauconite, we created a workshop that consists of a short presentation and 4 interesting experiments. First, we will be inspecting a sample of glauconite sand under a microscope and see the beautiful crystallic structure it forms. For the second experiment, the students are able to heat the glauconite sand and witness as it changes color. The third experiment lets the students observe glauconite's filtrating properties by filtrating an iron solution. And lastly, we will be preparing our own green paint with just glauconite and products anyone has in their kitchen. Here are some clips of students in action. Thank you so much for watching our video. We hope you enjoyed and you learned something new.
green sandstone. It sounds a little bit like from Minecraft game. So why you pick this material?
Actually, when our teacher suggested us to it, we actually had never heard of it before. So we automatically thought that, well, we should definitely learn something about it.
And I guess since this was new, what was the most interesting fact that you figure out during the work on the project?
As I said, we did not know anything about it. So it was quite a shock to us that you can actually use it in so many useful ways, like make fertilizer out of it and filtrate water and all of the things together, like, wow.
Yes, I guess it's really interesting once somebody is trying to figure out what the material, what the actually objects are made of. That the wide variety of different minerals and metals. So thank you very much for joining.
Okay, now it's time again for Italy. Okay, we have here the school from Scarabelli, Guinea, class 4th A.
Good morning, it's 11 o'clock a.m. We are connecting from the Scarabelli Guinea Institute. Right in this place, the 4th AA class, the student invented a board game called Light Life. Came with me.
Hi, nice to meet you. How did you have the idea of the game?
Hi, nice to meet you too. We have the idea of the game participating into the project Raw Materials promoted by the Consiglio Nazionale della Ricerca, the CNR. In the first lesson, Dr. Emilia Benvenuti showed us bulbs made of different materials according to their function, like fluorescent bulbs, incandescent light bulbs, LEDs and OLEDs. After this first lesson, the idea of the project was to create a product of informal purposes. Thanks to this opportunity, our class decided to develop a game to point out the biggest environmental issues we face today, for example, the climate change. The purpose of this project was to reinforce people's awareness of the importance of saving energy using specific light equipment. Energy efficiency also means protecting the environment. Replacing just one incandescent light bulb with an efficient LED bulb contributes to reducing environmental impacts due to fossil fuels and greenhouse gas emissions.
We have also got different types of cards, which are the monuments, 4 types of light bulbs, and the basic material cards. In the monument card, we see the required lumen to be lit up, the urn in green points, and the initial price to light it up. In the bulbs, we see the lumen that they can offer to the monuments, the degree of pollution that will be subtracted from your main green points at the end of the game, the consumption per bulb that will be subtracted from the urn of the monument per turn, and the production cost per single light bulb at the industries. The basic material is just a card to remember how many of them we have and will be consumed when you create a batch of bulbs in one turn. In this game, there are 4 types of squares. The start square, the mine squares. When a player lands on a mine square, they have the option to use their green points to purchase it. The mine can remain inactive for a maximum of 3 rounds, otherwise the player would lose his mine. There are four types of mine squares. Tungsten mine, silicon dust mine, rare earth mine, and the laboratory. The shop, when a player lands on this square, they have the option to purchase a maximum of 1 basic material card from 50 grip points. And the industry square. When a player lands on this square, they have the opportunity to produce a specific quantity of light bulbs, as indicated on the light bulb card.
Okay, only a very few delegates of all the class, because I know that all class was involved, no? So how many of you compose the class? How many students are in the class?
We are 20 students, and we divide the parts by making the game of the intention, the creativity of the game. So someone made also a story, a backstory about the game. Someone made the graphic parts, like the cards, the board, and things like that. We cooperate very well because everyone has his plan and collaborated with us. So it was fine.
Okay, so a great teamwork, we can say. So did you test the game also in your class, but also in another situation, or no?
Yeah, we tested the game many times. We tested the game also in Holland, in a science conference, and the game worked very well. It's very funny.
Yeah, because from this class was selected some delegate that went to Netherlands to take part to the international science fair. So you test in international contest, we can say, international environment. Okay, and so what did you learn about lightning that maybe you before you didn't know? Okay, some concept, some knowledge.
We learned about the existence of OLEDs that for me is the future of lighting because they made of organic compounds that are easily created in the laboratory and they aren't an environment problem like LEDs, fluorescent bulbs or incandescent light bulbs. So this game teaches about it because you win the game if you use the right light bulbs. So this is the thing I learned.
Okay, perfect. So also for this game there is the chance to test. So they have the stand. Okay, so they can wait for you for playing a game all together. So thanks again. Okay, you want to say another thing?
We use our creativity and knowledge in every part of this project. We are very proud of it. So if you want to learn with fun, come to play with us this afternoon. I'd like to thank my teachers, my classmates, and the CNR.
Thank you. Thank you. Thank you.
Thank you very much. Now, I would like to invite a team from my hometown, from Brno, from the Czech Republic.
With the school system, do you have the feeling that you are learning things you'll never have any use for, while your potential is running away? We have a solution for you. Wealth of the Earth Competition. Hurry up! Wait, what's this all about?
Wealth of the Earth is a multidisciplinary competition for high school teams of future entrepreneurs, scientists and innovators. It is organized by Masaryk University and tests your knowledge of business, marketing, but also geology or modern technology.
That sounds tough, but don't give up. You can do it. Remember that you are playing for the ticket to your university. Because if your team scores in the top 3, you are guaranteed to get the acceptance to Masaryk University. Plus, winning a competition like this opens the doors to a world of new opportunities.
They don't think you come with all the knowledge in your head. You can't become an expert without learning. So the first step is to study the relevant industry, especially physics, geology and economics.
The studying is just a fancy word for looking on the internet.
In the second step, you'll focus on a specific problem combining what you've learned in the previous phase. For example, we focused on natural gas production. We knew the location of our deposit, the effective porosity and how much money we need in each year of extraction. We had to figure out how much gas we could extract and how long. We had to make a prediction of how much money we can sell it for in the coming years, taking into account the ongoing energy crisis. Last but not least, we had to think about the social credit, the impact on nature, and propose the revitalization of the deposit after the end of mining. Our work has shown that extraction at the site is financially viable and that the natural gas deposit can be revitalized after extraction, either by converting it into compressed air energy storage or by converting it into carbon dioxide storage.
It was fun.
The third and final step is to present your project in front of an expert committee.
This will help you improve your presentation skills and master your marketing strategy.
So I was the youngest one in the competition, and it was my first time I could try some kind of university work or project. So I'm actually very glad I did that.
I said to call the checker. It was this competition. But why? Simply it taught me a lot about skills that I could use in the professional and academic life. Now I finally know how to write academic texts or research papers.
I believe that the greatest benefit of this competition is that I'm already accepted to Maastricht University.
I really appreciate that I can improve my skills in teamwork.
We did it, and it was just amazing.
Thank you. So I think the topic of natural gas was discussed so many times since the Russian invasion to Ukraine that this is really up to date to talk about this. Now, what was the biggest challenge in this project?
Well, Albert, do you want to start?
Okay, so we might start with the task, with the assignment of this task, because we had to do a lot of research and study or learn a lot about the whole thing, like also about the science, but also about the economy. And I think that the best part of this competition is that that's a combination of economy and science, so it's suitable for all people who would like to once probably become a tech entrepreneurs, and it helped us develop a lot of entrepreneurship skills that would be useful for the next generation of businessmen.
Yeah, for me, the most demanding task was definitely a presentation, because I've got difficulties with talking in front of audience. So that was definitely like the great opportunity to really practice this skill. So I'm really glad I had the chance to speak in front of yeah, in front of jury. Yeah.
Yeah, and that wasn't all, because after all of this work, the organizers were like, hey, it's 9 p.m., and you think you've presented your work, you think you are all done, but we are gonna give you a new assignment, because we had this project of a gas mining deposit, and the organizers created a hypothetical situation where the mining has stopped. The people in the city are very nervous because they think that there could be some leakage and that it could be dangerous. Our investor is also nervous because when the people are nervous, everybody's nervous, and he's thinking about stopping investing in us. And it was like 9 p.m. And we had to present the solution in 9 a.m. So we had to work during the whole night without any sleep. And it was pretty fun and a very good surprise for us.
Thank you. That was a very comprehensive answer. So thank you very much, and good luck with your further studies. So, now the final video and final project from Bologna, obviously couldn't be different. Liceo Fermi, please, students please from Liceo Fermi, come here please.
On March 10th, we visited the CNR Institute, the National Research Center, where Professor D'Ambrosio showed us his latest research on rare earth metals. We also saw some stands and tried some experiments about the CNR projects. CNR proposed us to participate in an initiative to promote science. We formed 5 groups in which we had to find the best way to communicate some specific topics to the public. This video will show you our products, especially the winner one. It's Monday and on Wednesday there will be a chemistry test on rare earths. So we have thought, what's the best way to review the topic? Why not create a game that may help us? That's why we have come up with a Guess Who about these chemicals, which helps you go over it and have fun with your friends. The game Elements Groups, periodic table game, is a card game inspired by the mini-family Jeux de Famille game, to bring them closer to the world of chemistry and familiarize with some of the best-known elements of the periodic table. Our team has decided to tackle the issue of cryogenics and how it can be applied to different fields, for example, to aeronautics, medicine or food industry. We have written a scientific article to appear in a scientific magazine addressed to a young public. Our project is a scientific article that illustrates the countless uses of lithium. The lutetium is a silvery white rare earth metal that is often used in research and industry for its high melting point and magnetic properties. When we were first told about this project, we immediately thought of making a board game, because we felt it could be a fun and a useful way to learn more about rare earth elements. While we were looking for information about the topic, we came up with the idea of creating a new version of the popular game Risico. In this revisited version, players have to conquer extraction sites instead of countries all around the world. We also inserted some new features, such as pollution points and the chance of creating objects by combining specific rare earths. Even though we faced some troubles in trying to keep the game balanced or find reliable sources in the web, we managed to obtain results we are pretty satisfied with.
Okay. Please come. Hold the class here. Okay. Okay, you have the map. Okay. So, you realize a lot of educational games, no? So, for who you have thought to develop this game? For instance, the game that you have in your hand, the rare.
Okay. So we realized this game for a public of non-experts people. And you can play this game if you're 10, like, yeah, so, 10 years old. Yeah. Well.
Did you test in any classes of your school, maybe some younger student, or no, you don't have the time, no?
No, we haven't had the time to test the game with other people, but we tested ourselves just to see if it was balanced enough to be an actual game.
I think to check if it is balanced for the time, for the rules, it's essential if you want to create a game. So you prepare this game, and the other game, there is a game for children. Who developed the game for children? Yeah? Okay. How did you think to develop a game for children?
We thought that it was important also for children to start knowing something about the chemistry and so on. So we create this game for them.
Yes, and also you develop some articles, some papers. So who are the team that prepare the text? Oh, nobody, no, everybody disappear. No, I'm sure that among you there is somebody, but okay. So do you want to add something? Do you want to share some funny aspect of your project, or yeah? Do you want to say something? How was to work on this kind of project? It's something not usual during a period at school, no? Usually you prepare maybe some description of an experiment, or maybe you have to do research for find information, but it's not easy to develop games on scientific topics.
Yes, it was very interesting, and it was like a very different project that we usually do at school, and it was a very nice experience because we got to see scientific subject like chemics in a very different way, a very different perspective.
It was also very difficult to find a game that could explain all the things that we learn at the CNR, and that was useful for this.
So is it possible to play the game, some of the game today? So also invite, the invitation we can invite all to play the games with you this afternoon. So thanks again for your effort, your school, your teacher. Okay. Dear all, I think for the first time in my life I am in advance, not late, but anyway, okay. The morning section is ended. So now, before leaving this conference hall, I want to remind you that for the people that will stay here at CNR also for the afternoon, it's important to subscribe the activities. No? So there are some workshops for students, one for teacher, and also some seminar. In the afternoon. For the seminar, the entrance is free, so it's not necessary to subscribe anything, but for the workshop is important, no? So please, before have lunch, go decide which kind of activities you want to do, and then have lunch. The same for the coffee break, the lunch for teacher and partners of RMS School are in the rooms back the stage, and for you in the entrance hall. So thanks to all, thanks for your effort, and good luck for the future.
Okay, so we're few number of friends, quite an intimate gathering, but I think you will enjoy it. So this is the first of our afternoon seminars, and let me introduce you Dr. Professor Zuzana Gotovac-Atlagic. Did I pronounce it correctly? Okay. Zuzana, I call her Zuzana, that's enough. And she will present this short seminar on modern application of European mineral resources in nanotechnology. That's really interesting and very up-to-date seminar. Thank you, Zuzana.
Thank you, Silvia, very much. My dear audience, thank you for coming. We are a little but selective team, and maybe it sounds unusual to talk nanotechnologies in Balkans. Yeah, but it's a serious story of me and my colleagues, of course, at University of Banja Luka. So I hope you will enjoy a few words about it. I will keep my presentation at about 15 minutes, I think, isn't it? So let's start a little bit. For those who don't know, Bosnia and Herzegovina is very near to Italy, just across Adriatic Sea. It's a little country, but very diverse in mineral resources, which makes it so suitable for nanotechnologies as well. Banja Luka is our city. As you see, it's on the northwest. So, just a few words. This is our faculty, a fancy picture of it. For those who might come to study to Banja Luka, you are very welcome. We do have an English program for students, and you can spend 3 months preparing and learning our language if you would like so. So these are just the departments that we have, and you can choose. It's just next to the national government, so it's a beautiful location with a beautiful park very nearby. So this is chemistry department. These are real students. These are not Googled pictures. So these are all my real students, some lovely pictures of them working on the equipment. And you see what do we educate them. And as you see this data, 90% of students remain in Bosnia, which is a very good number, and we are proud of it. So this is showing that chemists have a job in Bosnia. It's meaning actually that our industry is really recovering and developing very fast. So this is the structure of my presentation today. I will tell you a little bit why international collaboration and exchanges are so important. And then I will tell you what is this material crisis story about, because all this project about RM at school also came out from the story of material crisis, raw material crisis in particular. And I will show you 2 examples of very exciting nanotechnologies that we are working on recently at Banja Luka University, so I hope you will like them. Okay, so importance of international exchange. I'm not going to be boring here, so I'm going to show you some funny pictures. You see me younger and probably lighter, about 15 kilos less than today. But I'm still happy, the same happy girl in these pictures. And you can obviously guess that I had the privilege to study in Japan. I spent 5 years and a half in Tokyo under a wonderful professor, where I obviously learned nanotechnologies. So this was a beautiful challenge coming back to my home country, where I was practically the first engineer of nanotechnology, not only in Bosnia, but in whole of Balkans. So it was quite also a responsibility for me in the future, and I really enjoyed that role to teach my students this important subject. Of course, you see that I have been enjoying the international exchange, and I think this on these pictures, you don't see the photos from my university time, but from my life with my host family, with my Japanese friends, and it was very important and motivational for me to study hard, because I was well accepted in a society. Yes, I speak Japanese. I know 1,800 letters, but this comes with it. I needed to learn it to study chemistry seriously. But it was not a big deal. I mean, I really enjoyed the hospitality of Japan. But after coming back home, there was a reality waiting for me. Obviously, from the first pictures, I had to get married immediately. Otherwise, my parents would be totally disappointed. So I did meet a very nice papa of my children, Mr. Milan. And we do have a normal and happy family life at home. And I'm really always proud to say that Bosnia is having a very good tradition of excellent kindergartens. So our children are guarded for 8 hours. They are safe in kindergartens. So I, as a scientist or any other mother who works in the industry or anywhere else, can really dedicate to the work. So this is why I enjoy the science, and I'm a mommy of 3 little girls. Some of them are big now. So let's talk this material crisis, which is a very serious subject. And from this story about material crisis, also the RMED schools project have started. You know, you heard that from Madame Armida. Okay, we have to preserve the sustainability of European material chains, raw material, what's going on? So what is actually going on? The problem with material chain in Europe is the fact that Western Europe in particular, we must say European Union, has mostly abandoned mining. You know, you have stopped mining. So it was good at the first time because, okay, we said, yeah, we're happy, we have ecology, we have environmental protection, very nice, we will close all the mines and we will be happy forever. No, you're not going to be happy forever. Now you are paying to the Asian countries or to Australia huge prices for some important raw materials that we need in Europe. So this is the reality. We have to be really cruel about it. And recycling is wonderful, but you cannot recycle everything 100%. So you will still need raw materials, of course. I love recycling as well. I don't just love mines. But this fact about preferring the environmental protection instead of mining has led European Union to the problem in material chain sustainability. You know, not only that we don't have material, you don't have materials, we have in Bosnia. So not only that European Union has problem with materials, but you have problem with the qualified staff. There is a very small number of mining engineers, of excellent geologists, and even technicians who would work in mine. Even if you have a magic wand of Harry Potter wand and say, okay, now we open 100 mines all around Europe, you don't have staff to work there. So that's a large problem. It's a 20 or 30 years of gap in education of young people in material sciences, as we say, mining, geology, and of course chemistry and chemical technologies. But the good news is that Bosnia never abandoned mining. I am very naughty and happy about this fact because we have 8 centuries of completely continuous mining and education of young staff and students in this area. So the idea is now for us to spread a positive message of what happened to Bosnia. You most probably do know that we have some unfortunate history. We did have a terrible civil war 30 years ago. But even after the civil war, Bosnia recovered just like that. I mean about the economy. So economy recovered very easily because we do have so many resources. We still have our mining going on. And at this moment, mining companies are so strong and so hardworking that the average miner in Bosnia has a salary like I do have at the National University as a professor. And I'm satisfied with my salary. So I'm happy for miners to have a good salary. I have good salary, they have good salary. So this is beautiful news. So these are some good salaries, people are motivated to keep working, and in some mines we have people who are 5th, 6th, 7th generation of the miners. Not to talk about especially engineers and people who deal with it. So it was very good for us. It helped us to recover from the crisis time. And this is just a selection of minerals, which of course you can see at our stand on the fair here nearby. So let's check a little bit, not just the mining. My story about nanotechnology today is going to be also about the tailings. You know, tailings is a sludge, a garbage that becomes available after the ores or mining resources are processed. And there is a lot of these. These are some pictures from around the world. You can find tailings everywhere. So they are becoming more and more interesting because even though Bosnia is also, of course, someday going to spend all of our mine resources, so we will also have to rely on the tailings and all of the world as well. So what can we use tailings for? There are all different kinds of metals, especially metal mining tailings are interesting because you can relatively easily extract the metals from them, but still there is a lot of research needed in that area, and this is where we go. So we had a really wonderful pleasure this summer to host our students from Italia with Professor Alberto, who were with us, and we took them to the iron mine in Bosnia. Iron mine in Bosnia is the largest one in Balkans, not in Europe, but on Balkans, yes. And it is a strong international company. It's called ArcelorMittal, the second largest steel producer in the world. And you see the realistic picture. This is some of the visits of us with our students there. And although the mine itself looks quite not so environmentally friendly, but nevertheless, the mining system is really so good and the water is completely circulated. So actually there is not much harm to the environment in the sense of water and particles. Of course, we have to dig a big hole, but nevertheless, this hole is going to become an artificial lake and it's going to form a completely new ecosystem later. So this is good, very good practice in mining, it's possible. And why is iron still so important? Iron sounds like something ordinary and usual in our lives, but it is still very, very important. It is, maybe you don't know, but it is the most recycled material in the world. Iron and steel can be recycled endlessly, doesn't matter how many times. In average, even today, every steel contains some percent of recycled iron or the steel, usually about 20–30% or so. And sometimes in electric furnaces, which are the strongest one to recycle them, even 100% of recycled, this rusty old iron can be converted again to the superior steels. So this is very, very exciting news about iron. And when we come about, okay, I don't want to sound like a person who doesn't like ecology or environmental engineering, but of course for environmental engineering and clean energy sources, again, you really need a lot of iron in all of these technologies, especially solar panels or wind turbines, as you can guess. So iron is really important. Here are just some little snaps from the recent papers about other applications, not so technical, not so metallurgical, but chemical applications of iron, which are also still very important, especially in the area of catalysts. So why catalysts? Catalysts because catalysts, when you use catalysts, you reduce the need for energy in chemical industry. And energy is everything. If energy is expensive, as you can now experience because you don't buy gas from one cheap location, I'm not going to say which one. And we do buy from that cheap location, so we are fine. And we still produce a lot of energy, especially hydro energy in Bosnia. So if you use catalysts in the process, the energy becomes less necessary and the process becomes much cheaper. So this is one very excellent news about us, is that Bosnia is completely self-sustainable in terms of iron. I think we might be the only country in the world in doing so. So we produce all the iron we need for all purposes, especially, of course, for construction, etc. So we do have this large iron mine, which I've shown, and the steel plant, which employs over 2,000 people. And still, I was very, very curious about this tailings problem. Tailings. Bosnian mine also has a tailing, of course. It's like an artificial lake full of sludge, brownish sludge. You can see the images, how it actually looks. These are my students, Dragana and Marco. So we were like, okay, let's check what is inside. What else can we find actually in the mining sludge, in tailings? Remember the word tailings. So we tried to actually purify it a little and did the analysis, and of course, as you can guess, we found still plenty of iron which could not be extracted immediately. So we said, okay, if there's so much iron, let's first remove the iron and then we will talk about potentially other metals. We do find traces of lithium or something like that, but you cannot produce something if it's too expensive to extract it. So we stuck to the cheaper one, but this is, so to say, relatively speaking, cheaper one, because iron can also have a good price in market if it is produced as a nanomaterial. So we try to make nanomaterials. You see our extraction process. It's just a simple laboratory procedures, just done with care and concentrating a lot. So we were really able to get good concentrated solutions of iron ions and make some very, very nice nanomaterials using so-called microemulsion methods. I'm very good in this. I learned this one in Japan. So we are just making different variations to have our original method in that. And we really, really obtained some very nice samples, which were, as you can guess, analyzed in Japan as well, because I like to involve my former colleagues from the study time. And we found out that we really were able to produce some very high quality materials. Some of them, for example, like this middle one, highly crystalline hematite with carbon shell. This is our sample produced 100% from the waste from the iron mine Omarska. But this is an exciting material because there was 11 papers at that time which were telling that this kind of nanomaterials can be used as a node in the lithium batteries. So always we come to lithium. We do hope that sodium will replace lithium, but nevertheless, it's good to have as ecological components in batteries as possible. And of course, hematite is so harmless that you can eat it if you like. Nothing's going to happen to you. Hematite is a simple iron oxide. You can really do no harm to you. And so imagine if half of the batteries becomes something not so dangerous or not so harmful. So we published this story in an adequate paper, and we also obtained a national patent in Bosnia. Our method was, of course, original, very cheap and economical, so we did submit and obtain the patent. So I had a good question from some colleague, oh, did you patent it in the European Union? And I said, no, iron mine is only in Bosnia at this moment, so I just need my patent in Bosnia. So this was very good news. And I'm just going to show you one more short story. Again, one of the stories that we have presented to our colleagues when they visited us this summer. It is a story about the nanotechnologies in kaolinite. Kaolinite. Kaolinite is a material which is a plaster, it's a clay. You might have heard about it. And again, of course, we are taking interest into it because we have it a lot. We had 110 million tons of kaolinite on the north of Bosnia, around River Sava, which is flowing from Croatia and the northern Bosnia. So we do have a large deposit. This deposit was used for production of the very fine ceramics before, but now kaolinite is becoming much more than just ceramics. So I'm showing here the case of the factory with whom we collaborate in this research, and our colleagues with Alberto also have visited it. It's a very state-of-the-art factory producing facades. Okay, so paints for the houses. Facades are, of course, necessary more and more. There's a construction work all around the world, and this factory is already internationally present. But to be competitive in the facades industry, you need something original. So I'm here prizing the Italian discoveries of the stories of the ecological facades, eco-facades, how they are called. So what is the story about eco-facades? The facades that should actually purify the air. They should clean, they should dissolve or degrade toxic molecules present in the air, usually caused by humans, as we know. So if these toxic molecules from the atmosphere jump into the eco-facade that we produce, there is always UV light from sun coming, and catalytically these molecules could degrade. So it's a lovely story. We don't know how big these effects are, but they are scientifically proven. And it would be interesting to have cheap, available eco-facades everywhere, wouldn't it? So we are trying to develop our own. Usually these technologies go as simply as just adding titanium dioxide into the powder. And the powder is usually kaolinite. The filler, the filling material of the facades is very usually kaolinite. So what we did actually in our country is this study of the Bosnian kaolinite. We are in the very early phase with kaolinite. You see the images of my assistant Maria. You can meet her there in the fair or here in this line. So this is Maria's master thesis. At this moment, Maria is actually doing something related to the geopolymers from kaolinite, but she has done a very nice characterization of the kaolinite that we have in Bosnia. And on the basis of her data and some data for some other materials, we are going to continue with this story of ecofacades. So even less than 1% of titanium dioxide into the facade mass can help a lot to have these catalytic effects. So instead of kaolinite, for this moment, the best results we have is with material called pyrophyllite. I'm going to kill you with my stories about millions of tons of this or that in Bosnia, but I hope you will remember. So pyrophyllite is also one wonderful clay. Pyrophyllite, the largest deposit in the world, is again in Bosnia, actually in Herzegovina. I have to be careful because it's on the south of our country. We have 38 million tons of deposit in the city of Konjic. And this deposit at this moment is there is some research concession. So this is not a living mine, but there is a permission for research. And that's what we actually did. We have some very, very fine data about this pyrophyllite. So this graphicon that you see above is so-called XRD. This is a Röntgen crystallinity check of this material, which we actually treated with some special combinations of acids, etc. And what we actually did is not that we add titanium dioxide into the mixture of facade, but we profited from the fact that there is titanium dioxide inside already. So we just uncovered it. We opened it up a little, that structure of pyrophyllite, so that titanium dioxide comes out. And this is clearly proven with this XRD data. Of course, we hypothesize about the same thing like our Italian colleagues or any other person who works with ecofacade, that it's going to have these wonderful effects. So this idea, since we had so much data, it was submitted to the very nice competition last year, and it won a Balkanese prize for the best university innovation idea. It was in competition of 183 teams and 6 prizes. So you see my students, Dragana and Sunčita above, they won not just a prize, but it was 5,000 euro. So it was good for them, of course. We were in the final year of their school, so it was a very prestigious thing and still useful. So we continue. This is the stage where we are. We continue with these studies. So what I will hope that you will bring from my lecture today is this story about the necessity of mining. We do have to have mines around Europe, not just in Bosnia. We can't do it all. We're just 4 million people. So please advocate for opening the mines and still keeping them green. Mines can be green if it's carefully managed, if it's a serious approach of young engineers and people who work there. Mines can really reduce the pollution to the absolute minimum. And then in few decades, Europe is going to be again 100% self-sustainable, both in terms of metallurgical materials or nanotechnologies. But until then, Bosnia will probably become a hub of nanotechnology in Europe. So you will come to us. I thank you very much, dear friends, and I hope I wasn't too long or slow, but nevertheless, I'm open also for questions now or later, if you like. Thank you.
So are there questions from the audience? Don't you have been inspired by this very enthusiastic presentation? I should have been younger. I would come studying in Bosnia or in Japan.
Thank you.
So there is a question over there. Just a second, I'll bring you the microphone.
So my question would be, you mentioned these decontamination of the air using the titanium dioxide coating, and I saw that you have sort of a graphic there, but what happens to the nitrogen part? So it had like a NOx and then an arrow, and it became somehow carbon dioxide and water? What really happens there? What's the mechanism, right?
That was a good question, and you were watching my graphs very well. With nitrogen oxide, it's not so difficult story. Of course, this catalytic effect is practically helping it out to dissolve as much as possible into native nitrogen, which is N2, and which is about, I think, 70% or so in the air. So that's not such a complicated story with nitrogen oxide, which are for sure part of the pollution story, but there are also always, toxic organic molecules present in the air, especially in the area where maybe the wood is still burnt, etc., or near to the chemical factories, etc. So even larger molecules could potentially be dissolved into smaller ones. So we'll see. We are going to make a little chamber. Now we have this project with the chamber. We're going to make the chamber, and we are going to connect it to the mass spectrometer to really measure the effects. We're going to have a little plate with our facade, injecting toxic gases and checking out what's coming out. Thank you. It was a very mature question for a young person. Thank you so much.
He doesn't look like a student.
He's a pupil from Hungary. I remember him. Excellent.
So nice.
Thank
I
you.
really appreciate this attention on the environmental side of the question.
Thank you. Oh, he can come to Banja Luka to study. I keep the chamber for you. We wait for you.
Are there other questions?
Anything else?
For Susanna?
Thank you very much for listening.
So I think we can, Alberto, do you agree we can proceed with the next speaker?
Yes, Eleonora Polo at the present is sick, so she can't come for his presentation, so I think we have to go to the
next
one, to the next one, yes.
And the next one is Veronica, that I see over there. Veronica Sokorova. I'm not very good at pronouncing surnames, so I'm sorry. And our next speaker is Veronica from Euromines, and she will present us European mining, the key enabler of the green and digital transition. European best practices.
Yes. Okay, so hello everybody once again. This time from a different position as a speaker, actually. Maybe I will. Maybe I will take them. So let me introduce some best practices in European mining. This is what members of Euromines are actually doing. Could I move the slides, or should I tell you to move the slides? But I can do. Yeah. I would like to start with the slide that is something what we have already discussed today. We just want to say that more ambitious climate targets, the more mining and raw materials will actually be needed. And the increase of these materials is actually quite substantial. Overall, it's at least 6 times, but for certain minerals and metals, it's at least, it can be up to 42 times, which is a massive increase. There is a big recycling potential, which is up to 30 to 40%, but still, we will not be able in the next couple of years to fulfill the need of the industry for the raw materials for the next decades. So what we want to say is that we definitely need mining, as Susanna just mentioned. Without that, we won't be able to continue with the European industry. And we see actually what is causing to be totally dependent on one country. You've seen probably the restrictions China is imposing at the moment on gallium, germanium, now graphite as of last week, and this will probably continue. So more dependent we will be on these specific materials, the easiest will be to blackmail us with different conditions. And I just wanted to say that this is also included in the Green Deal. This is nothing contradicting the Green Deal. If we want renewable energy, we definitely need minerals and metals.
And let me show you just a couple of examples of how mining can be actually done in a sustainable way and how it is done in a sustainable way in Europe. I hope the video is not. There is a video, but I don't think it's. I don't know if it's. This is from PowerPoint. You from PDF, you don't have the PowerPoint? Okay, well, there was a video, but I don't think we will be able to see it. Nope. No worries, no worries. I will go through the slide and maybe I can provide the video later on to everybody to see. But don't worry, it's in PowerPoint, not in the PDF, but don't worry. Let me continue. I will give you just a couple of examples. One of the top examples of a sustainable mining, I think, is located behind the Polar Circle in Kiruna, where the iron ore mine is, I do not know, more than 100 years, and it's the biggest iron ore mine, underground iron ore mine in the world. Believe me or not, they have more than 500 kilometers of roads underground. It's a massive mine. They are currently extracting from the level of 1,600, and there is an entire city built underground. But what they are doing, they are trying to produce iron ore. Well, they are not trying to produce, they are actually already producing iron ore without any CO2. It's, for the moment, it's only pilot plant, but they obviously are very successful because they already delivered first material. And with this, they actually invested only LKB 30 to 40 billion euros to produce this sponge iron ore. And this will overall save 35 million tons of CO2 in steel making, which is absolutely impressive. But that's unfortunately the only one in the world that is doing this. This is how it looks. In Luleå, they built a hybrid. It's called hybrid plant. This is a joint project of LKB, who is the iron ore producer, the SSAB, who is the steel producer, and Vattenfall, which is the Swedish energy provider built on hydropower. Thanks to that, thanks to Vattenfall, they are able to meet the energy demand for producing this CO2-free sponge iron ore, because this process is actually very energy intensive. But the result with this production can be very impressive. They can decrease the overall emissions, CO2 emission of Sweden by 10% and 7% in Finland, which is a very extensive amount. So that was hybrid. To give you another example that is not in Scandinavia, it's Poland. Obviously, the conditions are very different in different countries. In Sweden, they work a lot with hydropower. In Poland, they installed 10,000 solar panels, and they plan to be climate neutral by 2050. And also the production of copper by KGHM in Poland is huge. It's one of the biggest copper producers in Europe. Another example is Arecha Magnesita. They are producing magnesite, and magnesite is actually needed for all the refractories, also extremely, very energy intensive process, and they have really massive investments to capture CO2 and to work towards climate neutrality. Another example from Sweden, Boliden was mentioned today in one of the projects. Boliden is producing wide variety of metals, but the core production is copper, And they have this copper mark with a low carbon copper. It's not completely without any CO2 at all, but they managed to reduce the CO2 massively with the new copper production. And the same applies to zinc. The new products emits less than 1 ton of CO2 emissions per ton of zinc, which is also the top in the world. And the production of this low carbon zinc started in actually last year, in February last year. Back to LKB, they discovered that the old waste that was accumulated on the sites for many years, they actually discovered that they can still extract fluorine and gypsum out of these waste materials. So they are basically turning waste product into resources that can be used in various chemical, medical applications, and of course gypsum for the buildings construction site. They also in LKB are very innovative. They have this robotic dog which they call Spot, and this was quite famous last year when we were showing this during the Raw Materials Week. So they are sending Spot to the places where it can be a little bit dangerous for people or where the emissions can be too high for human being. And the dog can have a drone on his back and actually investigate the terrain very well. So this is the full digitalization is also one of the steps forward to the sustainable mining. In Aitik, this is one of the mines of Boliden. It's actually the biggest copper mine in Europe, open copper mine. And these huge tracks, if you stand close by to the track, you are really very tiny person because the tire is, I do not know, really 6 times bigger than you are. And they installed electric line, which is today about 3 kilometers, and all the trucks are basically powered by electricity. So there are no emissions from the digital engines. Maybe you noticed this one. This is the new rare earth deposit in Kiruna. The rare earth is actually, it's one of the topics that is continuously discussed these days because we are highly dependent, especially on China, for delivering these rare earth materials. Now, in January this year, the CEO of LKB announced this new deposit, which seemed to be really huge. And it can actually be reached from the iron ore mine. They dig this long tunnel, and most probably there will be the possibility to actually mine this site from just reaching out from the existing iron ore mine, because these are very close to each other. So this is a very promising site. The problem is obviously with the permitting times, because when they announced it, that there was a journalist from Financial Times asking, so why you don't start tomorrow or maybe next year? Well, the shortest permitting time, the very shortest, if nothing goes wrong, is 10 years, but most probably it's 15 years or 20 years. So who knows what we will need in 15 or 20 years with the current development. So hopefully these times will really shorten to be able to use this potential. So these were a couple of cases of sustainable mining in Europe, and we want to say that this is sustainable mining in Europe and for Europe. Because if we will never be able to be totally independent concerning the materials. That is 100% clear. But to be fully dependent, it's another story, and we should do our best and show that we can do sustainable mining, responsible mining in Europe. That would be it.
So, are there questions from the audience? Just 15 days ago, we have a meeting in the Italian Ministry for Economic Development, and a representative of the organization that recycle steel and iron was worried because they don't have steel waste enough for their plant. So this is one of the reasons, because new mines are needed, because the recycling is very efficient but not perfect, and but the economy is growing, so much more metals are needed in our economy, and this is a very interesting point of view of the new way to extract. But about the rare earth and the rare metals in general, together with the subject you talked us about before, are any other deposit in view here around in Europe? This is the question.
If there are, yes, there are. There are actually deposits that looks very promising. But yeah, there is a long way to go. The permission process is very difficult. This is one thing. But we were just discussing during the coffee break the importance of the awareness issue, and that's why these projects like RMS schools are very important, because if at the end you get the permission, but you won't get the acceptance by the local community, then all your effort and all your investments were wasted, because if the local community or if the civil society, if they don't see the reason why they actually would need these materials, they would never allow to be extracted. So there is a potential there. Another problem in Europe is that Europe is underexplored, because most of the geological surveys in Europe were undergone in 50s and 60s, and since then, only in very few parts of Europe there are detailed geological surveys. Most of the other countries are much more explored, or continents are much more explored than Europe, and therefore we still do not know actually what is the full potential of Europe.
So, yeah, okay, thanks.
Thank you very much for the presentation. So actually my question was very related. So the first part you already answered was about what is the policy from Europe with respect to new mining site, and second part is what about offshore site? Is Europe interested in these ones, which usually brings less concern from the local community?
Overall, I think these days is Europe interested, because now with the latest legislation on the Critical Raw Materials Act, you see that actually raw materials are really the highest up on the political agenda. So whatever sources are available will be investigated. Now, if it is too late or not too late, we will see in the next couple of years. I would say it's very much on the edge. It might be too late. Because, as I already mentioned, China is already squeezing us a lot, but there is a potential the others will squeeze us a lot. So let's see. And the problem is really that these projects are really so long-term that you can't really start from one day to the other. And I was just discussing with a new company producing graphite. They said we have already the processing plant built, which they manage within 1 year with all the permissions. They have a site, they have a big deposit, but they said we are not able to open this deposit within next 10 years. So until then, we will have to deliver the material from one country or another. Of course, the first choice would be China, because this is the biggest supplier. Another possibility is, of course, Africa or some of the African countries. But this just illustrates that Europe is unnecessarily losing while there is the potential.
If you don't mind, I would go also with one short, I don't know, is it a question, but more like I would like you to maybe agree with me in something. We are, of course, discussing now from my presentation and from yours also this unnecessary, like you said, dependence on other continents and countries in raw materials. But wouldn't you agree, Veronica, that we don't just have problem in this raw material chain, we generally in Europe have abandoned production. In general, consumer goods. The most shocking story for me was a colleague from France who said that they send their milk to Greece to produce yogurt and bring it back to France. And this was a true story, I mean. So we abandoned all kinds of productions. So do you know anything about the policies in general? I mean, we have to produce more of everything. Plastics, any kind of consumer goods, clothes, textiles, shoes.
Yes, pharmacy. It's all the same. Yeah, I think the last couple of years with COVID, with Russian invasion, with economic crisis and everything, it just shows us the way we went with relying on the others. Yes. It's not good.
Yeah, we're not producing.
And it's probably too soft to say it's not too good. It's actually too risky.
Yes.
So I think that the politicians are now recognizing the problem. They are acting.
Yes.
But it's a really
tough situation. People are not used to labor anymore, you know. Labor doesn't have to mean something terribly negative. I mean, it can be humane labor, just a normal work in a modern factory, you know, so.
Yep, that was a good comment.
I'm sorry, yeah, it was not more a question, but just sharing the worries. Thank you so much, Veronica. Anybody else, maybe?
Thanks.
All right, any other question? No? So
thank you.
No?
Thank you.
So thank you,
Veronica. And I think you can introduce the next speaker. Please, Silvia.
Okay, so let's proceed with the last speaker, the third one. And we switch a little bit subject. So we are talking nerdy to you. So the speaker is Lea Darling from RWTH Aachen from Germany, and her talk will be about talking nerdy to me, improving your science communication skills. Thank you, Lea.
Thank you, guys, and hi, everyone. A very exclusive session, but that's good. It's not bad. Maybe you wonder about the title. This is not a topic-wise or content-related presentation, as I'm not a geologist, I'm not a mining engineer, I'm a psychologist. Maybe you wonder why I'm here on stage, why I'm in the project, because we think educational skills matter also for scientists. And I choose this title because I like when people talk nerdy to me, but I want them to do it right. So maybe you will take some tips and hints how to effectively communicate your science results. Short introduction about me. This is me, like at least the head. I'm from Germany, the western part. I'm not from Aachen, but I'm working in Aachen, close to the border to Belgium and the Netherlands, in a big mechanical engineering institute, as you can see there. As I told you, I'm not a mechanical engineer, but I'm working with them, which is sometimes really interesting, challenging, but also enlightening, because working interdisciplinary means you always have to properly explain what you do, because you cannot know that anybody understands what you do. So this is something I learned when I talked to engineers and other scientists from natural sciences, that they face some issues about not being understood by people that are not their scientific peers. And that happens often. So let's talk a bit about talking nerdy. So imagine as you presented today, or some of you, you have wonderful research, but nobody understands. That's so sad. Why is that? There are actually two ways that we are focusing on today that you can use to improve your science communication. One of this is focusing on your audience, thinking before you have a presentation about who is sitting there, who's listening to me. Is that someone who's experienced in the topic, someone who's completely new to it, grandparents, aunts, family? Is that friends? Whatever it is, think of it before, and how to do it I will tell you later. And the second part is, what are your aims? What are you aiming at when you're presenting science results to others? We saw a lot of amazing videos today, and I feel some of them had different aims. Some maybe wanted to entertain, some wanted to inform, but it's very important to think of it before creating science communication. So let's first talk about the target group adaptation. Come in, welcome. Hi. So let's talk about the why, what, and how of target group adaptation. Why to adapt a presentation to a target group? Very easy. The focus is not on you. The focus is the recipient. So who is listening to your presentation is the one who should understand what you're doing. This means you have determined who is the audience, and you have to prepare your content so that it reaches your audience. Each target group has different needs, and each target group has to be addressed in a different way. So, what to consider? What is actually to consider when you're thinking about your audience? This might be one simple thing already applying for the presentations of today. You have a very heterogeneous audience, like people of different ages, people of different backgrounds, people of different interests, and this is something you have to have in mind. Also, opinions, expectations. Maybe the partners of the consortium are expecting something different from your science results than the peers who are also doing research. The prior knowledge. So for me, as a psychologist, a lot of presentations were like, wow, I don't understand a word. But for most of the peers that were listening to you today were like, this is known to me. This is a topic I'm also researching on. So it was very appropriate. I was the one who was maybe the alien in the room. Think about their benefits. How could they benefit from your presentation? Is there a call to action they can apply? And of course, the group size and their physical and mental form. I have the last presentation of today. I can think of not a big group size and maybe a bit of tiredness, a bit of, wow, that was a long and intense day. I do not want to have a lot of input, so I try to really keep it short for you today. So, how to address it? When you think of your audience, you could either imagine a person. I always say, if you can explain it to your grandparents, you will be able to explain it to anyone. That could be a good test for you. But other than that, you can create a persona, for example, thinking about a specific person that you're telling your results to. And if you're addressing them, tell them what their benefit is. Not, I'm going to show you today, these are my results and my methodology and my research institute. Tell them about your benefits and what you are going to take out of the presentation, what you have to change if you want to be more sustainable in mining, for example. So I guess we just had two very good examples before this presentation. So thanks to you. And if you have the second part in mind, the aims and structure of a presentation, that's actually very easy and something after I saw the videos, I was like, okay, they know how to do it. So also why, what, and how. Why to think about the aim of a presentation or what could be an aim of a presentation. As I already told you, you want to inform. Some people want to educate and explain, and I guess that was also the mission of some of the videos we saw today. But some also want to convince, because maybe they're presenting to an audience who gives money to researchers. You can inspire or motivate. You can eliminate uncertainties. And you can also decide just to entertain. That's fine, if this is the aim of your presentation. But I guess the most important aim that you should have in mind is people should have you in mind after the presentation. Be memorable. After this day, be the one who sticks in people's mind because your presentation was amazing. That's something that's not very easy to reach, to be honest. So, what to do? Really easy, really clear. Just structure your presentation in 3 main parts: a short introduction, about 15% of slides, time, whatever of your presentation, where you greet the audience, where you introduce yourself, where you tell a bit about your story, because I saw a lot of conference presentations where people started like this. Hello, these are my research results. I'm reading from my slide, and I guess you won't be, oh, no one saw me, sorry, but I need to read from my slide, and no one introduces himself. That was really, it was crazy, to be honest. So please say who you are if you do a presentation and nobody knows you. Then comes the main body of a presentation, 75% roundabout. Bring your main information, arguments, and after all, the conclusion, where it's really important to say what are the key points, what is the takeaway for the audience, and also what's the call to action, what do you want from them. How to do it? Choose a simple and concise, comprehensible structure. Prepare a logical sequence of your arguments, meaning bring your strongest arguments at the beginning or at the end. This is also psychological effects. Things that you say in the beginning and at the end will stick to people's mind. Everything in between is nice, la 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 la, and the brain will just not remember it. Say it in the beginning and at the end. And create nice transitions that make it easy to follow. So the work of thinking should be done by you, not by the audience. The audience should be taken with through a story. No complicated formulations. Try to explain terms and avoid heavy jargon. So it's not good to use a lot of words that people don't know. It sounds smart, it sounds intelligent, but if no one understands, what's the matter? I mean, who's profiting from it? And of course, that's a very easy thing to do. Try to use verbs like, we will do this and that. We are doing, or we are producing research results, and we can change our world towards more sustainability, for example. Instead of, we hope to create results that might help you in the future, but we are planning to make our planet better. So make it concrete. Visualization, very important. Eyes, ears, and hearts. So visualization helps you to somehow underline what you wanted to say, but this is something that goes in the emotional part of people's minds. So if you want to stay, or if you want to have a statement that sticks to somebody's mind, don't just say it, but support it with a picture. People either want to read or they will listen to you, but they cannot do both at the same time. So say something and support it with images. And less is more, maximum 2 to 3 media per presentation. I guess that's something really, really important, because if you show a video and then a slide and then you have I have a flip chart with me, and I have a poster with me, and you do everything at the same time, that's just overloading. So keep it simple and delete any information that is not necessary to convey your message. Key takeaways. Think about your audience. Be aware of your aim of the presentation. Talk about why a finding matters rather than how you reach that finding. And use a simple structure and images to support your statements. And my call to action is talk nerdy to me, but in the right way. And never forget, practice, practice, practice. You do not have to achieve all of this at the same time. So I would say if you already start to apply this to your research right now, you will be one of the best researchers in the future. thank you for listening.
So thank you very much, Leah. Are there questions from the audience? Well, I must confess that it's never too much to be reminded of these tips to give a successful and convincing presentation. I have a problem with the level of certainty you ask researchers to have in their presentation, because it is very difficult for us to be so assertive. We will do that. Yeah. We have reached, because we have always a degree of uncertainty in our results. But we will do our best to follow your tips. I see that there is a question from the audience. Yes,
Thank
Susanna.
Should be fine. 1, 2, 3. I'm Susanna. I was the first presenter.
I know.
And you just told me my peers understood everything and you didn't have a clue. I am proud of myself speaking simply so that everybody can understand. Please tell me this was just a routine sentence in your presentation and that you did understand most of my presentation, please.
I did, thank you. And
I
also enjoyed your personal introduction in the beginning that directly took people to your emotions. I was like, yes, that's a good example. I was talking about all the presentations about the raw materials topic today. And of course, I'm like in the project since 5 years already. I know most of the topics. I mostly understand what's happening, but it was an example.
Thank you very much, really. It was really good to repeat some of these good points. We are really trying hard in our team to as you say, make as lively and as understandable presentations. So this was a wonderful repetition of the good rules.
Thank you too.
Thank you so much.
A couple of questions like before. So from your personal experience being a psychologist working with engineers mainly, in your opinion, what are the keys for us working in physics or chemistry and then trying to explain our research to, let's say, not specialized people? What are the topics or the keywords that are most interesting or can catch the attention?
Ooh, that's a hard question, but I guess the first step is already taken by reflecting on that somebody might not understand what you're saying right away. I guess that's the first thing to do, and that's the best thing to do in the first place. So if you are aware that someone might not understand everything of your research, perfect. Then there's the way to change it. And I guess there's no list of buzzwords or keywords that I could tell you that is easy to understand, but I would say there are a lot of words or terms that are also used, for example, in psychology as in engineering, but in a completely different manner. So think about terms that might be somehow understandable in many ways and clarify what you mean by giving examples, by giving maybe applications of your research. Why does it matter to me? That makes it easier for me.
Maybe also more a comment than a question, is that usually in our industry we have troubles that a lot of people are talking about how and very often missing why. And that I think is crucially important in the presentations to say. But I think this should be distributed to all our colleagues and with a couple of exclamation marks saying, please use.
Thank you. When we did like 3 years in a row, we did a workshop that was called Talk Nerdy to Me with mining engineers. And I always used the Aramet Schools example, treasure in my pocket that I saw here like 5 years ago, which was a video of students in the first years. And I was like, this is an example of how does it work? Like, this is perfect. And they were like, oh yeah, okay. And I guess they really took something from it. So yeah, thank you.
I have a question. Nice presentation, thank you. I was thinking, because we are also presenting the video this day, I was thinking about a balance between being entertaining and as it is fun, and don't block the audience, so it is also professional and it's not like making too much fun of it. How do you think it is possible to find a balance between these two?
I guess most of you had a good balance, and as you said it's experience. If you are trying to be too funny and your results are not that strong, people will notice, I guess. And if you notice that being a presenter trying to be entertaining and then you feel like, ooh, maybe that was too much, you will feel it directly. Take it as a feedback and also try to fail as often as possible so you learn from it. So don't have the aim to do it perfectly from the beginning. It's completely fine to do it a bit too much entertaining, a bit too much information, and then finding your perfect middle way in between after years of experience.
Okay, and maybe I have one more question.
Yes, sure.
Because the scientific papers are kind of written in a very formal way, and do you think there is a way to make not only the presentation of them better, but to also maybe don't use as formal language and in the official papers, and to make also these original ones more popular and more funny and easier to understand?
Yes and no. I would say it's very important that your scientific community is addressed as the scientific community. So I think scientific research papers should be mainly scientific research papers. But what you can do is take your results from a scientific research paper and make it available to public audiences in white papers, for example. White paper is something that summarizes main results in a really easy formulated way that everyone can understand it, and you can reference to your original work, but still I would say it's also valid to have the scientific community and to have scientific words about science.
Thank you.
You're welcome.
Can I? I would like to ask you, do you have some psychological tips how to, when you are presenting, for example, when you have a publicum made of investors, how to make them think that you are right, even though if you're not right? Like,
this is manipulation.
yeah, but do you have some tips how to make it, like, to act really trustable for the audience?
Wow, that's...
Because imagine the situation that you are presenting the results of your work, and you would like to start a startup, but you have to present it in a very nice way to receive money from the investors. So how to do it?
That's a complex question, and I'm also not sure if I could really recommend to make something sound nice, which I do not find nice, or which is not nice in reality. So maybe I would rather think about this before. And if you have something that you are convinced of and you want to convince someone else, I guess they will notice that you are convinced by just first of all being convinced and showing that, and just making clear that this is something that matters to them. So what will change if they invest in your research project or in whatever you do? So I guess if you are convinced that it's good for you, they will probably not care as long as it doesn't matter for them. So that could maybe be one point, but there are many more, and I guess it could be a day talking about this. But I can recommend a lot of boot camps if you wish. Yeah.
Ethic principles cannot be overpassed by communication skills. So
yeah. So communication is a lot, and it's important, and I guess maybe there are people who could convince of something that's probably not right, or people don't find it right, but that is really high level, and I'm not sure if this should be the aim. So I would say content first, and then the communication of it.
So I am very proud of our Oh, sorry.
Okay, thank you very much.
Because I was happy we are in time, but you know there is time for another question.
Oh, thank you. One question. You said we have to be memorable with the presentation, and the other thing, we don't use more methods like 3 or 4 in a presentation. For example, videos. This is not. I thought if I use more methodologies, more methods, I have more memorable. This is not. I don't understand this problem. Thank you.
Not super easy to answer, but I would say if you are the one presenting 20 different media or 20 different ways to show what you did, then you are memorable, but maybe not as the best presenter. So I would say 2 to 3 media means your message should be very simple, so your ways to convey the message should also be simple. And within a video, of course, there are different media allowed, but this is the media of the video, right? So if you use a video and a PowerPoint presentation and a flip chart and a poster, and maybe you also have, I don't know, a dance prepared that underlines what you're showing, that's maybe a bit overloading. So it would be a sign for me that you would like to keep the attention away from the content, more to the media presenting the content. Is that understandable? Okay.
Any other questions? So, for the first time in history of RMAT schools, I think we are finished in perfect time. It's 4 p.m. So I invite you to go back to the main hall, and you will have in 15 minutes the best part of this day is the sharing of typical sweets from all over Europe. So I hope you enjoy it. And thank you for being here with us.
Thank you.